Okay, good afternoon, everyone. Thank you so much for joining this session. Today we are here for our day 2 of the A-level mathematics seminar. And this is how our program is going to run. We shall have a word of prayer. And then from there, we shall have a representative from the ministry in case Mr. Ronald is already on the call. And then after, we shall dig deep into our seminar. But allow me now to welcome a student from Top High School Chengera to lead us in a word of prayer. Okay. Yes, Top High, we can have one student and then they lead us in a word of prayer. Okay, I think we are failing to get Top High. We can humble ourselves and we have a word of prayer. Loving Father, we want to thank you for the gift of life. We want to thank you for bringing us here for our seminar. We want to ask you to bless us, shower us with the wisdom such that whatever thing we are going to be discussing in this seminar, it may be of good hope such that we can be in position to prepare ourselves very well for our end of cycle assessment and also our mock examinations. We make this prayer through Christ our Lord. Good afternoon once again. We would like to thank all the schools that are joining in from the different parts of the country. I understand it is an afternoon, and in some parts of the country, I know they do not have power, so they are still trying to see how they are going to join in. But we shall get started. The beauty, the recording is going to be available for those particular schools. Unfortunately, the representative from the ministry is not yet here, but we shall get started. When he comes in, he will be able to say something. Now, today we are here for our mathematics seminar, and I want to first briefly take you through how the math paper will look like or how the math paper is structured. Now, our math paper is structured in two sections. We have section 1, what we call section A and section B. So for both the papers, you'll have section A and then you'll have section B. Now, the total time for the paper is 3 hours. Your paper 1 will take 3 hours, and then also paper 2 is going to be taking 3 hours. Then every paper 1 has 5 items and paper 2 has 5 items in total. And in each of these papers, we shall have a compulsory item. In paper 1, there is one compulsory item you are supposed to do. In paper 2, there is also one compulsory item you are supposed to do. But when it comes to the second part is that you have in section B, you have 2 items too, and you have to do 2 items in section B. So in total, you are going to be doing 3 items, and those are the items that you are going to be handling. Now, what is very important? It is very important for you to plan better for each of the items you are going to do. Now that the paper is for 3 hours, you need to plan better that if for each of these items, how many minutes should you spend on the what? On the item. Now, if you are to do these items very well, it means that you need to plan better that you are able to finish the paper within the given time that they have given you. Now, for each of the items, dear students, as you approach it, ensure that you do not take more than 45 minutes on that item. If you have started on item 1, make sure that you plan. You can even set an alarm that after 45 minutes, you have been able to finish. So when you look at the time you have, you'll notice that you'll have 15 more minutes for each of the item. Here you'll have more 15, more 15, more 15. if you spend less than or equal to 15 minutes per item. Now, what does it mean? It means that now you are going to have another 45 minutes for you to plan and look at your work better. Otherwise, if you finish on time, like at 3 hours, it means that you're not going to have time to go through your work. So what are you going to do? For each of the item, make sure that you spend less than 45 minutes. But it does not mean that the item you will take 45 minutes. There are some items where you are going to find that you will spend 30 minutes. There are some items where you will need a lot of time. So now that extra time you have is the one that is going to help you to complete the paper very, very well. So that one, please take it into consideration that for each of the items, do not spend more than 15 minutes. You have not answered. And always, I want you to always start with that particular item you feel is easy for you, such that you can get the motivation for the other parts. Now, in paper 1, we have some sections. We have 2 sections, like I've said, section A and section B. And we have what we call the themes. Sometimes they can call them the constructs that you are supposed to do in those particular items. Now, I want to bring to your attention that when it comes to section A of paper 1 is going to be mainly about geometry. And when we talk about geometry, I want you now to write and summarize what do you need to know in geometry. What are the main things under geometry? Now, in geometry, we have coordinate geometry 1. And under coordinate geometry 1, the major thing you need to know is what we call the straight line. You need to know what a straight line is. So this is where you're going to look at things. This is straight line. That is coordinate geometry 1. Straight line where you know the midpoint, you know the gradient. That is the major thing in coordinate geometry 1. Now, when it comes to coordinate geometry 2, what do you need to know? In coordinate geometry 2, I want you to focus on the following. Focus on what is the locus. Focus on a circle. Focus on a parabola and then the ellipse. Those are the major things you need to know in that section. So coordinate geometry 1 and 2 is going to contain those things. Know what a straight line is. That means that you need to know the gradient, the midpoint, and the rest of that, the distance between the 2 lines and the rest. Then also when it comes to coordinate geometry 2, focus on locus, focus on circle, where you find the equation of a circle, focus on a parabola, and focus on the ellipse. Now, when it comes to trigonometry in that section, what are the major things? Now, when it comes to your trigonometry, these are the things I want you to focus on. As you are revising, you're going to identify, do I know this? Now, here under trigonometry, know what we call the trigonometric ratios. That is the sine, the cosine, the tan, the secant, the cosecant. Those are the major things. Then also still here, I want you to know the graphs of trigonometry. That is the sine curve, know how to draw cosine curve, and know how to use a tan curve. Now, when you are looking at the curves, I want you to look at what we call the maximum, what we call the minimum of the curve. What are the shapes of the curve? Like in case you meet a cos curve, do you know that a cos has a maximum of 1? You know that that is the curve that runs like that? Then you need to know that if I meet a sine curve, do I know that a sine curve looks like this? Do I know how a tan curve looks like? Now, that's what you need to look out for when you are revising trigonometry. But also in trigonometry, I want you to focus on what we call compound angles. You need to know about compound angles. And then the last thing is you need to know the identities, the trigonometric identities, the sine squared plus cos squared is equal to theta. And then how to solve trigonometric equations, or what we can call trigonometric equations. Now, that's what you need to know when it comes to trigonometry. Now, then the next one is what we call the vectors. Now, as you are approaching the vectors, I want you to focus on vectors in 3 dimensions. That is the I, the J, and the K. Then number 2, focus on what we call the line in 2 and 3 dimensions, and what we call the planes. Those are the major things under the vectors, meaning that you need to know how do you find the equation of a plane? How do you find the point of intersection when you have the planes? How do you find the vector equation of a line? How do you find the angle between two vectors? How do you find the collinearity? Now, that is what you need to look at when it comes to that part of geometry. Now, when it comes to the part section B, we have part 1 and part 2. And we have what we call algebra and then what we call the calculus. Now, when it comes to numerical concepts, what are those things you need to know? Now, under numerical concepts, I want you to know what we call indices. Here, know the indices. Here, I expect you to know the laws of indices, the addition, the subtraction, how do you multiply? Then, under this, I want you to know about logarithms. You need to know the laws of logarithms, how to add, how to subtract, how to change the bases for logarithms. Then the last one here, you need to know what we call the surds. How do you multiply? How do you rationalize? How do you write your trigonometric functions in form of surds? Now, that is the major thing you need to know when it comes to numerical concept. Now, when it comes to equations and inequalities, now here you need to know that under equations and inequalities, what do I need? Now, one of the major things you need to know here is what we call simultaneous equations in 2 variables and 3 variables. You need to know how do we solve simultaneous equations using the law-equivalent formula, using the substitution, using the elimination method. You need to know how do we solve. Then when it comes to inequalities, you need to know how do we solve inequalities. Now that is under equations and inequalities. Now when it comes to simultaneous equations, they can cut across both papers. You can find them even in section A, you can find them in section B, you can find them in paper 1, you can find them in paper 2. Still under equation and inequalities, I want you to know what we call quadratics. How do you solve quadratic equations? And here, I want you also to know how to solve quadratic inequalities. How do you get the region that if you have a quadratic equation and they have told you to find the range, the domain, the range of the values, do you know how to solve such inequalities? Now you need to know, that is what you need to know when it comes. But also under equations and inequalities, I want you to know how to deal with polynomials. Here, polynomials of degree 3, degree 4, and so on. And you need to know, how do you get the factors? How do you know that this polynomial is giving a remainder? So I expect you to know about the remainder theorem. I expect you to know how to deal with that. Then we have what we call permutations and combinations. Now, when it comes to permutations and combinations, I want you to know about them. How do you arrange things? How do you know how many words can be formed in this particular thing? That is under permutations and combinations. Now, when it comes to the next one, which is the series. Series, what is the most important thing? Now, under series, I want you to know what we call the APs, what we call the GPs. Those are two things. You need to know the APs, you need to know the GPs. And what is the difference? One has a common difference, another one has a common ratio. Then under still series is where I want you to know what you call proof by induction. You looked at how you prove something by induction. So you need to know what you call proof by induction. And then the last thing under series, please make sure that you know what you call the binomial expansion. Now that is under the series. Then when it comes to the last one, under algebra, is what we call complex numbers. I do expect that you have done complex numbers, or some of you are yet to do them. Now, under complex numbers, that's where you need to know the algebra of complex numbers. That's where you need to know what we call the Agad diagrams, how to draw the Agad diagrams. I expect you to know what we call the De Moivre theorem. I expect you to know the locus. Those are the major things when it comes to complex numbers, and also how to solve imaginary numbers. Then, when it comes to calculus, one of the topics you covered in senior 5 was partial fractions. You covered partial fractions in senior 5 term 1. Now here you need to know that under partial fractions, how many types do we have? Then you need to know that here, I need to know how do I deal with linear factors? That is number 1. You need to know under partial fractions, how do I deal with quadratic factors? How do I deal with repeated factors? How do we deal with improper fractions? Now, those are the things. Now, as you are revising, as you are preparing for the paper, ask yourself in partial fraction, if I'm given a linear a linear function or a linear factor, do I know how to expand into partial fractions? Then you ask yourself, what about when I have a quadratic factor? Do I know how to expand it? Then you ask yourself, what about when we have repeated roots? You'll find repeated factors, 3x plus 2 squared. Do you know how to deal with those repeated factors? But also, what about when I have improper fraction? How do I deal with that? Then from there, I want you to go to what we call differentiation. Now, differentiation in senior 5, you cover one part, and also in senior 6, there is a part that you cover under differentiation. But when it comes to differentiation, the things that you need to know are, you need to know, how do I obtain the gradient function? How do I deal with implicit functions? How do I deal with the product and quotient rule? Do you know the product and the quotient rule? Do you know how to apply differentiation on rates of change, velocity, and acceleration? Now, that's where you're going to find here. So in calculus, this is where you're going to find there is a vector mechanics that can be brought under differentiation 1 and 2. Because under differentiation, under calculus, you're going to find rates of change, you're going to find applications of velocity, applications of acceleration, you're going to find turning points. That is under your differentiation 1. Meaning that when you are revising here, there is that part you need to remember from vector mechanics. Sometimes they have been calling it vector mechanics. When it comes to differentiation 2, I need you to know, do I know how to differentiate trigonometric functions? Do I know how to differentiate exponential functions? Do I know how to differentiate logarithmic functions, inverse functions? Then still it is under differentiation that you need to know what you call curve sketching. Here you looked at curve sketching 1 and curve sketching 2, whereby when you are given a function, do you know how to sketch that function? Then also it is still in the same that you need to know what we call the Maclaurin's theory. Now that is under differentiation. Now, as you are summarizing, as you are revising as a candidate, those are the things you are going to focus on. Those are the things you are going to say that now in differentiation, I need to look at, do I know how to differentiate trigonometric functions? Do I know how to differentiate exponential functions? Do I know how to differentiate logarithmic functions, the natural logs? Do I know how to draw curves? Curve sketching when they have given me a function? Do I know what we call the Maclaurin's theorem? Do I know the rates of change? Do I know how to deal with vector mechanics, the velocity, the acceleration? Now, all that is under calculus, under the differentiation. Now, when it comes to integration, also you need to be knowing that under integration 1, what do I need to know? That under integration, I'm going to focus on the following. That I'm going to focus on how to integrate indefinite integrals. I'm going to look at how to integrate definite integrals. I'm going to look at how do I find the area that is being bounded by curves. Here it is still under integration where you're going to look at solids of revolution under this same part. It is still here where you're going to look at what called the mean value of functions. It's here where you're going to look at area enclosed, because they are going to tell you that the curve has been enclosed, that this is the flow of the river. Which part of the river is this and this? Now, this is the part where you need to know integration 1 and integration 2. And now those are the things you need to expect, and those are the things you need to know. Now, this is where you need to look at the different approaches of solving, of dealing with the integration. Now, this is where you need now to evaluate yourself and ask yourself, do I know how to change variables? Do I know how to integrate exponential and logarithmic functions? Do I know how to deal with even and odd powers? of sine, cosine, the tans, and the rest of that. It is here where you need to know how to apply the factor formulae, how to deal with inverse trigonometric functions, how to deal with t substitution. This is where you need to know the application that partial fractions can be brought in integration, whereby they are going to tell you, you are going to find a model that has been modeled by something like that. And now maybe they want you to estimate the area. And there you need to know that now I have to apply my knowledge of partial fractions for me to be able to integrate such a function. This is where you need to know how to integrate by parts. This is still under the integration 1 and integration 2. Now, as we continue, now here I'm giving you a summary of the things I want you to know as you prepare yourselves very well. Now, when it comes to the last one is differential equations. Under differential equations, what do you need to know? You need to know, do you know how to deal with first order differential equations? Do you know how to form differential equations? Do you know the different words they use, the rates of change, the rate of increase? Do you know the exponential growth? Do you know the the logarithmic growth and the rest of that? Now, that's what you need to know. But in order for you to be able to do this section very well, you need to be well conversant with how to differentiate and how to integrate, because this topic here of differential equation is depending, or it is dependent on differentiation and integration. But the application of partial fractions is going to come out vividly under differential equations. Now, as you prepare yourself, kindly, I want you to master how do we differentiate? How do you integrate? Remember, what you are doing here has an effect in paper 2. Now, you need to master this section very well, such that you do not get affected when it comes to paper 2. So, that is something you need to put into consideration. Now, when it comes to paper 2, now when it comes to paper 2, what are those things that you need to know in paper 2? Now, when it comes to paper 2, these are the things I want you to know. Number one, what we call the trapezium rule. Now, here you need to know the application of the trapezium rule. That what is the trapezium rule for? That the trapezium rule is one that is used to estimate the areas. Whenever you have areas of different figures that you want to get the area of a river, you want to get an area of a given section whereby the figure is not an irregular figure, you want to get its cross-section area. For you to be able to get a cross-section area of such a figure, then we use what we call a trapezium rule, and it is one of the approximation methods that they can ask you. But you need to know that if they are asking for area and they have told me about approximation, then that means that the method I'm going to use is going to be the trapezium rule. And as you are revising the trapezium rule, it is under this that you need to know how to estimate the areas. It is under this how you can estimate the integrals. I want also to bring to your attention that integrals can be used or are used to find areas. So when you find you are finding area, it means that you are integrating, much as also it can be used to find the volumes of given figures. So you need to know the trapezium rule, and under the trapezium rule, I want you to know also what we call the percentage errors, because here you are going to look at two approaches. In paper 2, you are going to be applying the knowledge of paper 1 and paper 2. So here you are going to find yourself that they are going to give you a section. Let me say they give you a section of a river, and they tell you to find the area of such a river. Now they are going to ask you that using the approximation method and also using the exact method, mean that you need to be well conversant with integration such that you can be able to do the number very well. And there is no way you are going to find a percentage error if you don't know how to integrate exactly, or depending on that. And when it comes to integration, the number can even involve integrating trigonometric functions. It can involve when it requires you to integrate by parts. Now that one, you need to be well conversant with it. Now, when it comes to iterative method, this is where you need to know your interpolation. This is where you need to know the interpolation and the extrapolation. This is where you need to learn how to estimate. Not all figures are going to be given to you, but do you know how to extrapolate a value that goes beyond? Do you know how to interpolate a value that is within? It is through here that you need to know how to locate roots. It is through this topic that you need to know what to call the Newton-Raphson method. The Newton-Raphson what? Method. And what is it used for? Now, when it comes to Newton-Raphson method is where you need to know that, hey, if they want to estimate the depth, they want to estimate the root of something, then that means that they are indirectly asking me to estimate or to use the Newton-Raphson method. They are going to be giving you a function, and they may tell you that we want you to estimate the depth where we can place something of this nature. Starting with this value, then you need to know that now I'm dealing with the iterative method. And which method am I going to use? I'm going to use the Newton-Raphson method. Then still it is under this where we are going to find the flowcharts. Flowcharts, that is where we find the algorithms, how to perform a dry run, that is under the numerical methods. Now, when it comes to data analysis and probability, here under descriptive statistics, dear students, I want you to know the major things, which we call the measure central tendencies. And when I talk about the measure central tendencies, I'm talking about the mean, I'm talking about the mode, I'm talking about the median. But still further, when it comes to these statistics, I expect you to know how to interpret. I expect you to know the quartiles, the deciles, the percentiles, all of those things under the descriptive statistics. I expect you to know how to deal with unequal class width when you are given, when you are plotting a histogram, when you are finding the mode, and the rest of that. Then it is where we find correlation and what we call scatter diagrams. You are going to be given data, and they will ask you to estimate, to predict, and the rest of that. You need to know how to comment on such data. That may be which kind of correlation is it? You know how to comment on significance and the rest of that. So that is what you need to know under that. So here you need to know how to draw graph. Do you know how to put a right scale on the graph? Now those are the things that you need to know under correlation and scatter diagram. Do you know the formula? Do you know how to use the Pearson? Do you know how to use the Kendall-Tau approach? Then when it comes to probability theory is wide. You need to know the applications of probability. You need to know what we call the random variables still in the same area. Then when it comes to the last part of dynamics, under dynamics is where you're going to look at the resultant and components of forces, friction, connected particles. This is where you need to know how to draw those the force diagrams, how to indicate. Do you know when you are resolving that in case you have an inclined plane, do you know how to represent the forces very well? Do you know how to represent this force? Do you know how to distinguish between a resolved force and a force that is not resolved? Do you know how to represent that? Here you use dotted lines to show the distinction that this is my force, that the dotted ones are the forces that have resolved, and the one that is bold is the one that is not resolved. Now that kind of knowledge is what you need here. Do you know that when you are doing dynamics, where a sketch is very important, where it is that you need to have a sketch for most of the numbers? Do you know how to represent them? Now that is the kind of knowledge, and that is the structure that our paper is going to be taking. So allow me to first end here, and then I want you to, as you are preparing to do your things, make sure that you have now that kind of summary, that you know that this is what I need for this particular paper. These are the different sections that I need to revise, such that in your revision, it becomes very clear for you to make the right choice and to know how you're going to approach. Now, yesterday, we started with the discussion of the different seminar items, and I hope that many of us who are here, you have already received the seminar items. We are going to have a discussion from each of the sections that we have here for the different numbers, and also we shall give you hints for the numbers that we shall not be able maybe to complete on time, and then we shall start from there. So allow me now to invite our first presenter, Ivy, to take us through her presentation. You are most welcome, Ivy.
Good afternoon, teachers, administrators, and my fellow students. My name is Kengoma Ivy, and I'm going to be taking us through item 3 of the questions teacher shared. I would like to request that the questions come in after I presented so that there are less interruptions. So allow me to share my screen. Okay. Okay. If you can see my screen, you can react, you can put a thumbs up, or you can type in the chat so that I'm able to know the number of people can see my screen. Okay. So item 3, I'm going to be only solving the first part. Yes, Precious Arinawe, you could unmute. Oh, I'm seeing you're reacting. Okay. So I'm going to be handling part A of item 3, and it reads, a government engineering team is constructing a tunnel through a coastal mountain to link two neighboring cities. Excavation begins simultaneously from opposite sides of the mountain. Using a three-dimensional coordinate system with origin O, where one unit represents 50 meters, the first excavation starts from point A, which is represented by the coordinates -3, -39 in the direction 2i plus 2j minus k, while the second excavation starts from point B, which has the coordinates -19, -7, and -3 in the direction 6i plus 3j plus 2k. The completed tunnel should not exceed 1.5 kilometers in length. Construction materials are delivered through a nearby Habara, where the height h meters of the tide t hours after midnight is modeled by that equation. Though I'm not going to continue because I think part A only requires that first part of the question. So the task reads, determine whether the proposed tunnel design satisfies the required engineering standards. So yesterday, during the first part of the seminar, the first thing that we're told to do is, after reading the scenario, we should start unpacking it and start thinking along the lines of the elements of construct teacher has just gone through. So when we read through this item, we're able to see that this item falls under the element of construct, geometry, and under geometry, we say that there are three main topics: vectors, trigonometry, coordinate geometry 1, and coordinate geometry 2. But when we look at part A in specific, we notice that the key topic here is vectors. And under vectors, we are looking at 3-dimension, because in the question they said using a 3-dimensional coordinate system. So they have hinted, or they have given us a clue that under vectors we're looking at the 3-dimension, because there's a 3-dimension and then the 2-dimension part. Yeah. So the first thing I did was to make a small introduction about what vectors are. So when you look at the first, I could say, square, we have the 3D vector equation of a line. So the equation of a line is the vector equation of a line passing through a point P is parallel to the direction vector. So we have our vector equation of a line right there. So you can quickly read through and see what I've presented here. Another key thing I want to talk about here is the parametric equation of a line and the Cartesian form of the equation of a line. So the vector equation of a line can be written in two other ways. That's the parametric equation, which we have here, where we basically equate the equation to x, y, and z. And then we also have the Cartesian form of the line, where we are eliminating the parameter t from the parametric equations so that we're able to get the Cartesian form. So that's a summary of what we need for this part A. So after this introduction, I began by illustrating what the question had told us. They told us there was a coastal mountain. So I drew a sketch of a mountain and that they're planning to excavate so that they have a tunnel. So this is point A. Let me annotate. Okay. So we have point A here, which I'm going to take as our first excavation point. And then we have point B here. And they have given us the position vectors for the vector OA, we have -3, 9, and for the position vector of B, we have -19, -7, and -3. And then they went ahead to tell us that for each unit represents 50 meters. So we are going to keep that in mind as we continue unpacking and answering the scenario given to us. So the first thing that we have to do is to find the vector equation of the first excavation and the second excavation. So I began by defining the things I'm going to use. I said let the vector equation of the first excavation be represented by R1, and let the second excavation let the vector equation of the second excavation be represented by R2. So we say that this is a formula. We say that this is the formula of the vector equation, where we have the position vector plus lambda or mu times the direction they had given us. So after getting the first excavation, we said OA, we put our OA there, which was -3, -3, 9, plus our lambda times the direction vector, which was 2i, 2j, and -k. So when we add this all together, we're able to get -3 plus 2 lambda, -3 plus 2 lambda, 9 minus lambda. Then when it comes to the vector equation of the second excavation, one thing learners forget is that they come here, let me annotate, they come here and use lambda again. So when we are getting the vector equation of the second excavation or the second line, we have to make sure that we get a different, should I say, variable to use. You can use lambda and mu are the most used, but you can find something else to use so that you don't have lambda here and lambda here. So you have two different variables. So for the vector equation of the second excavation, we said R2 is equal to our position vector of B, which is OB, plus mu times the direction vector. So I've not written it well here. Or since it's a vector, should have something like that. Yes. Okay, so after that, we're able to get our vector equation of the second excavation, which is -19 plus 6 mu, -7 plus 3 mu, and then -3 plus 2 mu. Okay, go to the next slide. So the next thing we are going to do is to write our vector equations of the line in a parametric form. Someone might ask why we are changing it, why we are changing the vector equations to a parametric form. we need to get the intersection of the what they call it, of the vector equations. So to get the intersection of the vector equations, we need to get the parametric form so that we're able to equate the different components. So here we have x is equal to -3 plus 2 lambda, y is equal to -3 plus 2 lambda, and then z is equal to 9 minus lambda. So we got this by simply equating x, y, and z to the vector equation of the line R1. And then we did the same thing for our vector equation of the second excavation. So for the tunnels to meet or to intersect, R1 has to be equal to R2. So at this point, we are going to start equating the different components. So you come and state that for x components, you equate the x components. We said for R1, our x component is -3 plus 2 lambda is equal to the x component for R2, which is -19 plus 6 mu. So we take the 3 this side, and we bring mu this side, so that we have that we're able to get our first equation of of lambda minus 3 mu is equal to -8. So we do the same thing for the y components and for the z components, so that we're able to get, so that we're able to get 3 equations. I don't know if everyone is with me at that point. So after getting our 3 equations, we know that when we're working with intersection, we're going to solve simultaneously. So we can pick any of the 3 equations, any 2 of the 3 equations. But I chose to take equation 1 and equation 2 to solve simultaneously. So after solving simultaneously, we were able to first, if we got equation 1 and we're able to get lambda, as lambda is equal to 3 mu minus 8. Let me just go back so that you could see equation 1. Got lambda by taking this -3 mu to the other side to get lambda is equal to -8 minus, plus 3 mu. So after getting our value of lambda, we are going to substitute it into equation 2. And when we substitute it into equation 2, we see that we are getting our mu as -4. So after getting our mu as -4, we substitute the mu back into equation 1 so that we can get our lambda as 4. So after getting the values of lambda and mu, we are going to conclude that therefore the value of lambda is 4 and the value of mu is 4. So now to get the point of intersection, you're going to substitute your lambda or your mu into the equations. So I began by using my vector equation of a line R1, and I substituted for lambda, and I got the coordinates 5i, 5j, and 5k. And then just to cross-check, I verified using R2, and I substituted for mu, and I was also able to get the same thing. And this simply means that the lines intersect at the point 5i, 5j, and 5k. So there are 2 methods that we are going to use to find the distance of the tunnel. Because remember, our main goal is to find whether the distance of the tunnel exceeds 1.5 kilometers. So the first method, we're simply going to get the distance. We're going to say distance is equal to lambda times the magnitude of the direction vector, which we said is d. So for the first tunnel, we are going to say, we said our lambda is 4. So we say 4 times the magnitude of the direction vector. And we said our direction vector for the first tunnel is 2i, 2j, and -k. So after calculating, for most of us, we know how to get the magnitude. We just say square root of 2 squared plus 2 squared plus -1 squared. So our answer for the distance for the first tunnel is 12 units. Remember, they gave us the units and they said they are 12 because 1 unit is equal to 50 meters. So yes, don't forget the units. Some people are going to reach this point and just write 12 and forget the units. So for the second tunnel, we do the same thing. We say mu times the magnitude of the direction vector, which is 4 times, they say that the direction vector for the second excavation is 6i plus 3j plus 2k, and therefore we find its magnitude and multiply it by the 4, and we get 28 units. So that's the first way that we can get the distance of the two tunnels. Another method of finding the distance of the two tunnels, we have got the intersection. So someone can say, for the first tunnel from point A to the intersection, they can find the magnitude by saying, sorry, not the magnitude, the length of the tunnel by saying D is equal to, where D is the length, D is equal to square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So after getting that, you can see we are getting the same answer of 12 units for the first tunnel, and the second answer we're getting the same answer for the second tunnel, which is 28 units. So a learner can choose any method that they find easier. So after getting our units, we are going to add them. So after getting the total length for the different tunnels, we are going to add them so that we get the total length. So I came here and I said 12 plus 28 units is going to give us 40 units. But remember, they told us that 1 unit represents 50 meters. So a smart learner is going to come and say, since 1 unit represents 50 meters, they're going to say 40 times 50 to get 2,000 meters. But remember, our answer is supposed to be in kilometers. So we are going to convert the meters to kilometers. And we know that 1 kilometer is equal to 1,000 meters. So 200 meters is equal to 2 kilometers. And therefore, the length of the completed tunnel is equal to 2 kilometers. And like we emphasized yesterday, or as teacher Stephen emphasized yesterday, we always have to make sure, always have to conclude, because if we don't conclude, we have not responded to the task. So I came here and said, response or conclusion, the proposed tunnel design does not satisfy the required engineering standards because the completed tunnel length is 2 kilometers, which exceeds the 1.5 kilometers. And yes, that's the answer. So we come back to the scenario to see if we have been able to answer everything. They told us that the completed tunnel should not exceed 1.5 kilometers in length. So yes, we have been able to answer. So yes, if there are any questions, you can please you can raise up your hand and I'll be able to answer them. Thank you so much for listening.
Thank you so much, Ivy, for the wonderful presentation. In case of any questions on that part, kindly raise up your hand, or you can send it in the chat, and then she'll be able to respond. Okay. Thank you so much. Thank you so much. We are going to go to part 2, but I know, okay, there is a question. Top times high school, unmute.
My question for pardon the second method to finding the total length.
Okay.
Yeah.
Yes.
Okay, so for the second method, we said that we are going to use two things. We are going to use the position vector and the intersection we got, which was 5i, 5j, and 5k. So you can see here, let me just annotate. Here I came and said, this is my x, y. I'm going to use x, y, and z. X, y, z. And then this is my x, y, and z. So if you look at the formula that I put up here, we said x2 minus x1 squared. So you see here that this is our x2. Let's say this is 2, this is 1. So if this is our x2, which is 5, minus our x1, which is negative 3, squared, plus our y2, which is 5, minus our y1, which is negative 3, squared. Like that. So you continue. After subtracting, we know that 5 minus negative 3, we get 8. So we come here, we say 8 squared, and then 5 minus 9 is negative 4, so negative 4 squared. So 8 squared is 64, 8 squared is 64, and then negative 4 squared is 16. And then when we add 64 plus 64 plus 16, we get 144, and the square root of 144 is 12 units. And we do the exact same thing for the second channel. I hope it's making sense to the person who asked the question.
It is. Thank you for your part.
Okay, you're welcome.
Okay, we can have another one from Atwini.
Yes, good afternoon.
Good afternoon.
Yes, I was inquiring. I saw that it's as if we had an intersection whereby then after we add the distances or the magnitude of the two vectors. So, but it's as if from the sketch which you gave, I didn't see like an I didn't see like where they intersected. Can you please elaborate more? Yes, thank you.
Okay, so the sketch was just like an idea, like I was trying to picture or imagine what the scenario was requesting of us. So I'm just imagining, let me try and annotate here using a new thing. Okay, so if this is our point B and this is our point A, right? So I'm imagining that they are excavating on two different sides of the coastal mountain. So let's say our excavation began from here and it stops somewhere there. And then our second excavation from somewhere here and stops somewhere there. Let's say it's something like that. So this is the point of intersection. I think this is what I imagine, but this is like a better picture. Okay. So this is where they could have intersected because this is our second excavation, comes like this. This is our first excavation. So thanks so much for that question. Yeah, I think I've been able to elaborate on it better. So this is our point of intersection, which you said is 5I, 5J, and 5K. Yes. Thank you.
Thank you very much.
Yes.
Okay, thank you. There is another question in the chat, Ivy. What do those constants mean?
The constants mu and lambda.
I think.
Okay. Honestly, I'm not exactly sure what they mean, but I would like to assume that they are just like the scalar parameters. I don't know if you could explain more on that. Yes.
Thank you, Ivy. Now, when you look at the vector equation that Ivy has written for us, you can note that one, we have the position vector. Position vector is like the starting point. So R0 stands for the starting point, where we are starting from the original position. Like if you are coming from home and you are going towards your school, your home is the position vector. So that is R0. Then when you look at what she has displayed, you note that also there is D. D is always the vector parallel, is the directional vector. So now that one dictates the orientation. It dictates the steepness of a line. It shows you exactly how the line moves. Is the line rising? Is the line running? Is the line going down? Down, that is the direction. Now, t is what we call the parameter, or what she has been calling the scalar, or what we can call the variable. Now, whenever that value of t, for her case, that parameter, she has used the t. Sometimes they can use lambda, sometimes they can use mu. Now, that one shows you the scale, the scale to the direction vector. It shows you how big something it can be scaled down. Like it shows you the magnitude that this particular direction can be expanded, can be made bigger or smaller. Now that is the scalar or the variable, of which it changes that, like when you are moving from your home to the school, you'll find that you are going to turn east, then you turn north, then you turn west, like that. Now that is the kind of variable of that kind of t or lambda or mu. Whenever you have it, it changes the direction. So it changes the direction. For it can keep changing depending on where you are heading. Okay, so I'm going to thank you so much, Ivy. I'm going to now share my screen. I feel she has exhausted everything about that first part, and allow me that I join in from there, such that we continue with the item. Now, when you look at the item she has done the first part. And like she has told you that always whenever you meet these items, ensure that you conclude. So she has made a good conclusion. She has compared the values we had in the scenario with the output you obtain. Now, from the scenario, they went on and told us that construction materials are delivered through a nearby harbor, where height 8 meters of the tide towers after midnight is molded by dice. Now, I told you that whenever you meet this scenario, highlight the clues. Always there are clues that they are going to give you. So keep on highlighting. Now, this is one of the clues that they have given you. When you go on and read, they have told you the height of the tide at 2 hours. They have told you the height of the water at 8 hours. Now, when you look at these units, hours, it is an indicator that we are working with a 24-hour clock. And when you go on, they have told that heavy construction but can enter the harbor only when the water level is at least, now highlight the mathematical word, at least. Now, at least 5 meters means that it is greater than or equal to 5. Now, I want to bring to your attention that when it comes to landing, you have heard about ships on oceans. When they are to land, when they are going to go there, the depth of water matters a lot. In that if the water is not at a given height, they cannot land, or they cannot go in, they cannot be there. So now the water levels, very well, those who have been to the oceans, or those who have gone to the Indian Ocean or whatever ocean where you have been, you have noticed that on the ocean where we are, the water levels keep changing depending on the time of the day. There are times when you are going to find the sand completely, and then after 5 hours of coming back, you'll find there a lot of water. Now, remember these ships, for them to land, there must be water. So it means that there are times of the day when there is no water on a given area where they offload the materials. So now the question is asking us that this person who is in the ship, the person who is in the control, at what time does this person need to be there such that the water levels are at the height the ship must be on the water, on the water levels? Now that's what we are going to be finding. Now when you look at this item, it is looking at solving it's looking at solving trigonometric equation. But like I've said, when you go deep into this, you are going to find out that still in this same item, you are going to find that there is knowledge of what? Of inequalities. You are going to find that you are going to have the knowledge of solving simultaneous equation. Now we are going to first summarize. Whenever you receive the item, summarize your data. Now when you look at this particular item, we are going to summarize our data. They have given us the height, and they have told that during the construction period, the tide is 9.5 meters at 2 hours. Now that is the height. So we shall say that when our h is equal to 9.5 meters, what is the time? The time is 2 hours. Then, when you continue, when the height is at 3.5 meters, our time is equal to 8 hours. Please take note that hours, it means that we are working with the 24-hour clock. So you leave it the way it is. Now, what are we going to do? There is no way we are going to be able to solve this minus us getting the value of A and the value of B. So that is what we are going to first work out such that we can be able to solve. So now when you look at our equation, you note that our equation is H is equal to A plus B sine of 30 t, and then this is degrees. Now, whenever you are dealing with the trigonometry and you don't find the degrees, it is an indicator that your angle is measured in radians. So you please take note of that. So now we are going to start now working out. Now, as we are working out, we are going to substitute. This is our equation. So you are going to substitute. But as you are substituting, like I've told you, always have small subtitles. So now here we are going to say finding the values of the constants A and B. Finding the values of constants A and constants A and B. Now this one guides the person looking through your work that now you are finding this. Now you are finding this. Now we are going to substitute the first one. So we shall say now we shall have 9.5 is equal to A plus your B, which you don't know, then sine of 30, then times your T, which is 2 degrees. And now this one is going to give us 9.5 equals to A plus B sine of 60 degrees. Now this is my second equation. Now I go to the next one where we have H is equal to 3.5. I'm using this. So we shall have 3.5 equals to A plus B, and then I'll have the sine of the angle, which is 30 times time, which is 8 degrees. So this is going to give us 3.5 equaling to A plus, now what is your 30 times 8? So this is going to give us B sine of 240 degrees. Now, whenever you are solving values for constants and those values you are going to use them again, always ensure that your levels of accuracy are high. Always ensure that you are very, very accurate. Now, I'll give an example that depending on the calculator you have, when you place on your calculator, let me give here, sine of 60 degrees, you are going to get on your calculator sine of 60 degrees. You are going to get here 0.866025 Now, since we are still using the value of A and B, you are not going to be accurate if you write in decimal points. Now, when you are looking at trigonometry, you looked at special angles. Now, this is where that knowledge is applied, that whenever you meet special angles, I'm talking at an angle of 60 degrees, I'm talking at an angle of 30 degrees, I'm talking at an angle, speaking of an angle of 45 degrees, those ones always write a root. Those who have the advanced calculators, for them, they will be able to give you the value accurately. So when I find sine of 60, dear students, I'll write it as, from here, you know that sine is given by opposite out of hypotenuse. So I write this as root 3 out of 2. Some of you have calculators that can give you that. Some of you may not have those calculators that can give you that. Then I have sine of 240. Now this is where you need to know your trigonometry again. If I draw my quadrants like this, I know that from here up to here, those are 180 degrees. It means that if this is 270, it means that 240 is going to be here. Then you ask yourself, if I want to get that angle in there, which angle do I have? So I will say 270 minus 180. So this angle here is 60 degrees. So you notice that 240 will come up to this point. But the angle you have here is 60 degrees. And you know that in quadrants, all sine, time, and then the cos. Now, you know that in this quadrant, sine is negative. So what do you need to know? You need to know that now your sine of 240 is the same as the negative of sine of 60 degrees. Because in this quadrant where 240 stops, sine is negative. So meaning that now here you're going to come and say negative, but sine of 60 is the same as root 3 out of 2. So now instead of when you place your calc and you have sine of 240, you'll get negative 0.866. Now, because we want to be very accurate, we cannot place in that answer, but instead we shall place in the negative root of 3 out of 2. Now, in the position where you have sine of 240, here we shall replace with negative root 3 out of 2. In the position where we have sine 60, we shall go on and replace with root 3 out of 2. Hope that is very, very clear. But that is how now it comes about. So I'm going to remove this screen and then I'll replace with those values. So I'm going to come here in my equation and then I replace accordingly. So I'll have 9.5 equaling to our A plus B, then root 3 out of 2. But these two can multiply throughout. So you can work it out by multiplying. So I can say 9.5 times 2 is equal to A times 2, then plus B root of 3 times 2 out of 2. So when you place your calculator, 9.5 times 2, you get 19, equaling to 2A, then plus our root of 3B. And now this is another equation that you are going to deal with. Then when you come to the 3.5, you'll have your 3.5 is equal to A plus B. Then sine of 40, we have said we are going to replace with negative root 3 out of 2. Then you multiply through by 2. So 3.5 times 2, you end up with 7 equals to 2A, then minus root of 3 of B. And now this is another equation. Now, when you look at these two equations, they are in two variables, meaning that now you can solve them simultaneously. You can solve them using simultaneous equation. Okay, so you can solve them simultaneously. So now I'm going to come here and I say, now I have 19, 2A plus root of 3B. Then I have 7 equals to 2A minus root of 3B. Now, the two equations I have here, I can have two ways. When you look at the coefficients are the same. So you can say that same signs I subtract. You can either subtract or you add, depending on what you want to get. So when I have these two equations, I can decide to add. So when I add, you notice that I will have here my 19 plus 7, which is going to be our 26. Our 2A plus 2A is going to give us the 4A. But root of 3B plus negative root 3 of B, you can do it as side work. Root of 3B minus root of 3B is equal to 0. So now here, I'm going to end up having my A. You get 26 divided by 4, and you'll have your A as 6.5. And what are the units? When you look at the units from the question, you'll be able to put those particular units that they gave us in the question. Then from there, we are going to find out what about the value of B. Now, the value of B, you use any of the equations that you have. So I'm going to move to the next screen. So I'm going to move to the next screen. And when I move to the next screen, everything is going to disappear. Everything is going to be disappearing. So allow me to go to the another screen. So another screen, but to avoid things disappearing, allow me to change the pen. So we have obtained our value of A. we have obtained our value of A as 6.5. Now, to be able to get the value of B, we use any of the equations. So we had one of the equation as 9.5 plus A root of 3 out of 2B. Now you just substitute where there is A, you put 6.5. So this will be 9.5 equaling to 6.5 plus root of 3 out of 2B. Then you do the mathematics. This is 9.5 minus 6.5 equals to root 3 out of 2B. Now you place your calculator. Sometimes you want to do it in the head, but sometimes we make mistakes. So this is going to become 3 out of 3 out of 2 times B. When you multiply, you'll get now 6 equals to root of 3 times B. Then divide by root of 3, divide by root of 3. But now, dear students, I want also to bring it to your attention that never write your answer with a third in the denominator. Never write your answer with a third in the denominator. Always rationalize. So now we are going to rationalize by writing root of 3 times root of 3 times root of 3. So this is going to give us 6 root of 3 out of root 3 times root 3 is the same as root of 9, which will give you 6 root 3, and root of 9 is 3. So now here from your math, by 3 1, by 3 2, so you end up with 2 root of 3, and that is your B. Now, after obtaining the value of B, you are going to go and write your equation again, because when you look at the item, they wanted you to find what the values of A and what the value of B was, because they told you where A and B are constants. So we are going to go back and write our model and then say that now our H is equal to A, which is 6.5, then plus our B, which is 2 root of 3, and then we shall say sine of 30t, everything into degrees. Now that is the model. Now, when you are calculating this, you are solving spontaneous equation, kindly show us step by step. Do not go on and just place on your calculator. Use your calculator to just prove that your answers are correct. But make sure that you show how you are obtaining. And always make sure that you choose the approach or the method that is going to take less time, not the one that is lengthy. Let me say now someone here say, I'm going to use matrix method. Now, matrix method will lead you to the answer, but how long will it take you to get in there? Now, when we continue, they told us that heavy construction barges can enter the harbor only when the water level is at least 5 meters. And when you look at our H is the height of the height for the water levels. Now we are going to find out at what time is that when our water levels are 5. But because they use the word at least, it means that we need to find out at what time is our H greater than or equal to 5, such that now we know when this kind of ship can enter into the harbor. So I'm going to continue now and find out that part. Now I'm going to say, like I've told you, you're going to put small heading. So I'm going to say when water levels are at least at a height of 5 meters, of 5.0 meters. So that means that your H is greater than or equal to 5. Never use equals if they have used at least. So that means that I'm going to come here and I say 6.5 plus 2 root of 3 sine of 30 of t degrees is greater than or equal to 5. Then you are going to do your math. Now this is an addition. When it crosses, it becomes a subtraction. So we shall say 6.5 minus 6.5 plus 2 root 3 sine of 30t degrees is greater than or equal to 5 minus 6.5. So here we shall have 2 root of 3 sine of 30 t degrees is greater or equal to. Now, here you are going to have your 5 minus the 6.5, which gives us negative 1.5. Now, I know some of you may do it the other way around, but do not forget that whenever you are dividing by a negative, the sign of the inequality changes. But since this is positive, the sign will not change. So we shall have root of 3, 2 root of 3, sine of our 30 of t degrees is greater or equal to negative 1.5 out of 2 root of 3. So we shall end up with sine of 30t degrees greater or equal to negative 1.5 out of 2 root of 3. And now this is where I need you also to understand, dear students. The negative on the negative we have this side is showing us the quadrant where our sign, because this one is sine, is showing us the quadrant where sign is negative. So the first angle you find is always a reference angle. And when you are getting that angle, there is no need for you to put it a negative, because that negative is just an indicator where the sign is negative. So when you come back here, you know that all sine T and C. Now, what do you need? Remember, we have that sine of 30t now degrees is greater than or equal to negative 1.5 out of 2 root of 3. Now, when I'm finding my angle, I'm going to say 30t is greater than or equal to, now, the sine inverse, but of 1.5 out of 2 root of 3. But the first angle you get is what we call the reference angle. So the reference what? The reference angle. So reference angle is the one that we are finding sine inverse of 1.5 out of 2 root of 3. Now you place your calculator, because like we said that the levels of accuracy are very important at this stage. So when you place sine inverse of that, you are going to get your answers 25.6589. And now if you are writing an angle, and still we are, because we are continuing to use it, write to many decimal places such that you are very accurate. Now, after obtaining the reference angle, go to your quadrants and obtain where is sine negative. Sine is negative here in this quadrant, sine is negative in this quadrant. And whenever we are measuring, we always measure with respect to the x-axis. So I'm going to come here and I place my 25.6589. I'll come here, I place our 25.6589. Now, in order for us to measure the angle, always we measure in the clockwise direction. So I'll measure like this. This is the angle that is needed. And you know that from here up to here is 180. Then you add on this. So that means that here, our first angle is going to be greater than or equal to, the first angle we shall write, we are going to say 180 plus 25.6589, which is going to be an angle of 205.6589 degrees, comma. To get the next angle, I'm going to come like this. Up to this point, now that angle is going to be our 360 minus 25.6589. And that angle is going to be our 334.3411. Something like that. Now, after obtaining those angles that you are going to use, the next step is going to be, so here allow me now to show you just that this is the angle, and also here to show that those are the angles. Now, what do we need? We need to find the value of t. So what are we going to get? We shall have 30t greater than or equal to 205.6589 degrees. We shall have 334.3411. Now, the next step we are going to do is we are going to divide through by 30. So that means that your t should be greater than or equal to, so you do the first one, 205.6589 divided by 30. So here your t is going to be greater than or equal to, so you say 205.6589 divided by 30, and we shall end up getting 6.8555297, and these are hours. Then the next one we are going to get is going to be T is greater than or equal to 334.3411 divided by 30. And now this one is going to be T is greater than or equal to 334.3411 divided by 30. Sorry, 334.3411 divided by 30, and you'll get something like 11.1447, and these are hours. Now, when you look at our cycle, there are very many other angles that you would have obtained. But those ones you can try out and then you see. Take an example, someone who goes on and obtains an angle of above 360. It means that you have already rotated more than one turn. But remember that a clock can only rotate 360 degrees in 24 hours. So that's why we have considered one revolution. Yes, that's why we have considered to one revolution, because a clock goes on 24 hours, take on 360. So here we do not go on and have another kind of rotation. To how many degrees? I've said that if you are still using those particular values, write to as many decimal places such that your final answer is very, very accurate. Now, when you go back, we have got the time. That the time when the water levels will be at least 5, it's going to be at 6 hours, 0.855. But when you look at these hours, you cannot report them like this. So we are going to report them in a good way. So how are we going to report them in a good way? We are going to report them by writing them by writing hours and minutes. Now, when you look at these 6 hours, you are going to ask yourself, the 6 hours are what? So I'm going to write 6 hours. These are 6 hours, but plus, now this 0.08559297, you are going to convert them into minutes because these are hours. So convert them into minutes by multiplying by 60. So when you get 0.855297 times 60, you end up with 51 points. So this one is the same as 6 hours, then plus 51.31782. Now, this is where you need now to make a decision that now you are going to write it because in terms of minutes. So I'm going to write this as 6 hours, 6 hours and 51 minutes. These are the hours. 6:51. But when you are writing to a 24-hour clock, you can write it using 06:51 hours. Now, what about this side? Now, this side still are right because these are 11, then plus the 0.1447. But I convert them to our side, multiply by 60. So this is going to be 11, then plus how many minutes? So you say 0.1447, then times the 60, which is about 8.682. So this is going to be approximately 8.682 is approximately what? Approximately maybe 9. So you can say that this is 11 hours and 9 and 9 minutes. So these are the hours. So now that is and now when I'm writing, I want to write, so here I'm going to write like this, such that the 9 minutes comes out very well. So what does it mean? It means that now our water levels, when you look at the question, when I go back, they asked you that heavy constructions can enter the harbor only when the water level is at least 5 meters, while maintenance of the load jet can only be carried out when the water level is below 4 meters. The means of work and transport would use the finding investigate to determine whether the okay. Now we are on the second part. Calculate the operating periods for heavy construction barges and maintenance of the load jet. Hence, determine whether the proposed schedule satisfies the operational requirements. Now, for heavy construction badges, for them to enter the best operating periods from our calculations, we are going to conclude that it should be at 6:51 hours and at 11 and 9 minutes hours. Now, that is how you can conclude for that part. Then the second part that required us to determine, because there were two parts. The second one was telling us that maintenance of the jet is carried out when the water level is below. Now, when you look at the word below, it means it is less than 4 meters. That means that now you are going to go on and obtain what happens when we have less than 4. So that means the inequality in your equation here is going to change. You are going to change the inequality. So that means that you are going to, I don't know whether you are going to allow me that it's just a matter of us changing the inequality symbol in that equation, whereby now you allow me to just change the inequality. You do everything the same way, but here now when you reach here, the inequality is going to change. Okay, allow me to write the equation. So it means that your h should be less than the 4 because they told you below. So that means you have 6.5 plus the 2 root of 3 sine of 30 t degrees is less than 4. Now you do the mathematics. Okay, so here we shall have 2 root of 3 sine of 30 t degrees less than 4 minus 6.5. So this is going to be 2 root of 3 sine of 30 of t. Then you get your calculator, 4 minus 6.5, which is less than negative 2.5. Then you'll have your sine of 30 t degrees less than negative 2.5 out of 2 root of 3. Then you go back and now ask yourself, in which quadrants is sine negative? Sine is negative here, and also sine is negative in this quadrant. So that means that we are going to get our sine of 30t degrees and less than. So you place your calculator. Okay, I need to, we get the reference angle. So we shall have 30t degrees is less than the sine inverse of 2.5 out of 2 root of 3. I have ignored the negative. When I'm placing the calc, there's no need for me to place the negative because that one is just an indicator where sine is negative. So here you'll get your angle as 46.194. So this is 46.194. And then you start moving that. This is your first angle. So you'll have 180 plus 46.194, which is going to give us here less than 226.194. Then the second one is going to be 360 minus 46.194, which is going to give you 313.806. And this is the 30t everything degrees. Now to get your angles, then you solve that 30t is less than 226.194, and then get the time, which is 226.194 out of 30. You get that value. Then also you get 313.806 divided by 30. Here you are going to get your time as 10.4602 hours. Then 226.194 divided by 30. You are going to get your time as 7.5398. So now remember, we have said that we take them into the hours. Since the time given the scenario was in hours, so we shall write this as 7 hours. Then you convert the 0.5398. So 0.5398 times 60 gives us 32. So this is around 7 and 32 hours. Then for this one, it becomes less than the 10, that is 0.4602 times 60, and here you get your 10 to 28 hours. Now, that is the time. So now, when you go back to the scenario, when they asked us that while maintenance of the jet can only be carried out when the water level is below 4 meters. Now, the water level is, now here in your conclusion, you are going to say that the water level, the time when the water level is below 4, I don't know whether I went. So the time when the water levels is below, I think this is the one. The time when the water level is below 4 meters is when our time is less than 7 hours, 2 hours, and when the time is less than 10 and 28 hours. Now, that is the only time when we can have our jet, or when we have the water levels when they're below that. So now that's how you can make your conclusion. But in your conclusion, you justify why you are saying so, and then the time you have obtained. Please take note that if they have used inequality words, you'd stick to the inequality symbol, because they did not use 4. If they had told us that the maintenance occurs when the height is 4, now that one you would have used an equal sign. But if they use below, the words at most and the rest of that, then you have to follow the inequality symbols that you learned in equations and inequalities. So that's how you can attempt that part. Okay. May I welcome some questions in case you have a question? Okay. I'm going to, yes, stop, unmute.
Yes, I would like to inquire what is the
Yeah.
degree of accuracy if, for example, I happen to go the paper and I don't remember that, for example, sine of
I didn't pick you. Okay, but you were talking about the degree of accuracy. For when it comes to trigonometry, I would always encourage that make sure that you write your angles to at least 2 decimal places, not below that. More so, if at all, and if you are going to be using the angle somewhere, even I will encourage you write 4 decimal places, such that you are very, very what? Accurate. Why isn't it that the reference angles are not divided? Now, the reference angles are not part of the solution. A reference angle is just an indicator to show where your value lies, but they are not part of the solution. So when you get this reference angle, for whatever answer, dear students, you obtain, let me say you have obtained this answer. The moment you place sign of this answer, you must be able to get that. But once you get the sign of this reference angle, you will not get this what? This answer. So the reference angle shows you the position and the measurement. And please take note that always we measure with reference to the x-axis, that it is going to be here. Your reference angle will always be here. In this quadrant, your reference angle will be here. In this quadrant, your reference angle will be there. So always it is measured with reference to the x-axis. And if the domain for your angles is positive, always we move in the anti-clockwise direction. If the domain has a negative, then you move in the clockwise direction from the positive x-axis. Why the inequality sign? Why the inequality sign came in? Because of the mathematics, the mathematical words they used in the sentence, that here they use the word at least. So the word at least means greater than or equal to. Here they use the word below. Below means less than. Here, when they say below 4 meters, you are not sure whether it is 4, whether it is 3, whether it is 2, whether it is 1. But if they had said that it occurs when the water level is 4 meters, then that is very okay. Then that one is when you use equals. But if they are not sure, they will just say below 4 meters. Because whenever you are not sure about something, you cannot commit yourself. Always use the mathematical words that takes into consideration what you have. When do you use anti-clockwise and clockwise moves? I repeat, when it comes to angle measurement, if they have given you a domain, let me say negative 180 degrees, less than theta, less than maybe 360 degrees. Here you have a negative angle. So if your reference angle, let me say your reference angle is here, this here, your reference angle is here, something like that. Since you have a negative you move like this up to when you reach here. Now that is your angle. So you say 180 minus 30, you get 150. Now that angle, you write it as negative 150 degrees. That's what you need to know. If it is here, I'll move like this up to here. Then I'll have 330 degrees. But whenever you move in the clockwise, you put a negative. You put a negative. But now here, for this case, we shall eliminate it since our domain doesn't have negative. Now, in case it is positive, then positive we move in the clockwise direction. You move, that is one angle, so you'll include your 30 degrees. Move up to here, then you include your 180 plus the 30, which is 210 degrees. So in the anti-clockwise, they are positive. In the clockwise, they are negative. Okay, any last question? Now, when it comes to inequalities, in case maybe we had obtained something like this, maybe in case we had negative 3t less than or equal to maybe 40, something like that. Now here, if you are going to divide by negative, let me say this is t, you will say negative 3t out of negative. Now at this step, when you are dividing is where the inequality changes. So it will change and say greater than or equal to 40 divided by negative 3. And then you get your answers negative 40 out of 3. The signs only change if you are dividing by a negative. But if you are dealing with a positive, everything remains the same. What about angles that requires sine graphs? Oh, I've not obtained that well. But if you have a graph and maybe you have drawn your sine graph like that, for you to obtain the values, let me say you are solving something like this. Let me say sine 30 is equal to maybe 4 or 3, depending on what you have. It's just a matter of you drawing a straight line like this, where let me say this is where you have your 4, and then you read off this angle here, read off the angle here, read off the angle here, the angle there, depending on what you have. So that's how you deal with that part. I want to repeat that for such a case, I want you that when you are making your conclusion, have it in 2 parts. Like here, you notice that the first one was heavy construction barges can enter the harbor only on the water level. That is the first conclusion you are going to make. And then which kind of thing are you going to make? You base on that. Then the second conclusion you'd make is for the maintenance. Then also you make that kind of what? Or conclusion basing on that. So you make that condition. Sometimes they are going to give you, sometimes they are going to give you what? They are going to give you different things. But I also want you always to reason. Like, so you need always to reason, look at what they have given you, and then you must know how to respond accordingly. Sometimes they may ask you to compare things, so you go on. Never replace an inequality with an equal sign. Never replace, if the word is below, don't replace with an equal sign. So here I don't expect anything like an equal sign. And whenever it comes to geometry, make sure that your sketch is very good. Make sure that your sketch is a working sketch. Make sure that you have put direction. When you are dealing with vectors and you are drawing, ensure that the vectors you have drawn, you have clearly indicated the direction. Let me say you are drawing a vector, you are labeling your vector, please do not forget to include the what? to include your what? Your arrows to show the direction. When you are writing your vectors, do not forget to write the directions. I think you saw IV writing the directions, so don't forget to put the directions on your vectors because a vector quantity is represented represented by both the magnitude and then the direction. Okay, I think I've exhausted the different questions you had on that. Okay, I want to ask whether we have any other school that is ready to present. Do we have any school on the call? If we do not have any that is ready, I'm going to proceed and then I will go to the next number. Do we have any? If you are ready to present, you can put in the chat and indicate. But if you are not, we are going to do something now in paper 2. So allow me to share my screen again, and then we do another item in paper 2. Now in paper 2, I'm going to look at data analysis, data and probability. That's where I'm going to first concentrate. Then when we finish that, we shall go on and now look at the mechanics bit of it. So you can open your items and we look at item number 14. Now, when you look at item number 14, that is item number 14. Item number 14 is telling us that we have a fruit processing company that receives consignment of apples from different farmers for juice production. Before processing these apples, they always collect different samples, and in those different samples, they always make choices on whether the apples are good or bad, or whether they are going to take them on or whether they are not going to take them on. Now, where the world is heading, dear students, you are going to find out that for you to sell something, there is always a weight they need always consider. Like when you are entering some schools, they will say that for you to enter into our school, we need you to have obtained a first grade, or we want you to have obtained a second grade. But also you'll find good schools that say that, as long as you passed your P7, we are free to admit you. As long as you have below fourth, you have first grade, second, third, or fourth grade. Now that is it. Now also in companies, they always look out for that weight, that no, we want this particular weight. Now, as you are approaching these data and probability numbers, always I want you to extract information. The way you have obtained this information from the scenario is the same way you need to use it. Do not bring, now like when you look at the scenario here, the scenario is using weights. Now, dear students, don't bring in issues of what? Of you coming and say, now these are classes. Don't bring in your things of classes, that this is frequency. Where have you seen frequency here being used? So always stick to the language being used in the scenario. Now, number 2, before you jump onto to start, first ask yourself, what does the scenario want? So what does the scenario want me to do? So they went on and said that according to the assurance policy, only consignments with an estimated mean weight of at least 160 grams are accepted for processing. Now, that is an indicator that you need to know that, hey, they have mentioned something like mean weight. Next time they are going to mention average weight. Next time they will say the most, maybe the modest weight are the ones to be accepted. Now you need to know that here I need to calculate something of mean. Now you summarize, you say now they need something on mean weight. So when we talk about mean weight, what things need to come into your mind? That I will need one, get it from your formula, that the formula is summation of f of x out of summation of f. Mean that in my table, I must have x and there must be f. Then, the lightest 25% of the apples are classified as economy grade, the heaviest as premium grade, while the remaining apples are classified as standard grade. Now, this is where they have indirectly asked you to find something. Whenever you see percentages in your scenario, one of the things that need to come onto your mind is going to be cumulative frequency. It can either be a curve or it can be through calculation. That one should be very, very close to your mind. So when they tell us now, they have given us 3 categories. Remember now I'm still unpacking the scenario. So they have told us that they have basically 3 scenarios. So you know very well that 100%, if they have obtained only 25, this is going to be my 25%. And they have told us that also the other heaviest 25%. Now they have told that the lightest 25% are classified as economy. Now this is the economy. Those who have boarded the plane, you know we have what we call the economy class. So they have classified them as economy. Now, then they have told that the heaviest are called premium. So these are what we call premium, these heaviest. Now, in between here, we have people or category of people who love these ones. And that's what they have called the standard grade. Now, if you click very, very fast here, this is where now you need to remember that which idea are they talking about? Which idea involves dividing things into equal parts? And now this is the idea of quartiles. When you are learning descriptive statistics in Senior 5 Term 1, you looked at quartiles. And when you were looking at quartiles, you know that a quartile divides something into 4 equal parts. You looked at what you call the lower quartile, which is the lower 25%. You looked at the upper quartile, which is the upper 25%. And then you looked at what we call the median, which is the half the quartile. Now, this question indirectly was asking you question about a quartile, was testing, do you know how to find the lower quartile? Because for you to know the mean weight for the first lower 25%, you are finding the lower quartile. For you to find the one for the upper 25%, you are finding the upper quartile. And now you are going also to find out what is in between the two. Now, after knowing that, you are going to ask yourself, if I'm finding the quartiles, if I'm finding what do I need, that I will need cumulative frequency. Meaning that now in your table, you know what you are going to include, that I must have the value of x, I must have the cumulative frequency, I must have the class A boundary. Now that is the summary. That is how you are going to spend the 5 minutes, the 10 minutes, summarizing, unpacking what you are going to put within your table. Now, after understanding what you need in your form, because remember, you need even to remember the formula that I'm going to have cumulative minus cumulative frequency before out of frequency, then times class interval. Now, you need to remember that I will need the cumulative frequency in my table. I will need the frequency in my table. I will need the class boundary in my table. Now, this is how you summarize your data. Now, after summarizing your data, now you are going to present, because the competency on descriptive statistics requires a learner to be in position to present data, make informed decisions from the data obtained, and make a decision. Now, we are going to present our data. When you are presenting something to someone, always have a description. So we are going to start, because the question wanted us, the task, provide the evidence required by the management regarding the quality of the apple consignment. And what evidence does the management want? The management wants to find out whether the consignment they have obtained, its mean weight is at least 160 grams. Now, that is one of the conclusions you are going to make. But also the management wants to know what are the grading limits if something is to be considered as a low heaviest 25%. What should be their weight? If something is to be considered as the lightest, what should be its weight? What about standard? Now, those are the things you are going to have within your conclusion. So as we start, let me first pick a hand from Jacob. Yes, Jacob.
Yes, good afternoon.
Yes, good afternoon.
Thank you so much for this. On that, when you were talking about percentage, you said that if it is dealing with percentage, a learner is required to to draw an or give or the cumulative. So what if a learner uses
Oh, I've lost you. I said that when you meet a percentage, depending on the scenario you have, you may either use the graphical approach or you can use the calculation approach, depending on which approach is easy for you and depending on the time you have. But if you find out that using calculation is easier, then go in for the calculation. If you are not sure of the calculation, then feel free to go in for the graphical approach. Sometimes they may specify that they want it represented on a graph or using the graphical approach. Then that's when you use that specific one. But here you can use any of the two approaches and you go in for that one that is easier for you. Okay, so we are going to start. Now, one of the key things you need to know in data presentation is specify which data approach are you using. So now here we are going to say a frequency distribution table showing the weights. Have that title of your graph. So you'll say that a frequency distribution have the title always, never forget, right? Distribution table showing the weights of apples, or a frequency distribution table showing this and this. But what is very key is the word a frequency distribution table. You have specified the method you are going to present your data. Then from there, I want you always first extract the data from the way it is in the scenario. When you look at our scenario, they have started with weights. So we have weights, and if they have units, kindly indicate the units there. So we have our weights here. After the weights, when you look at our scenario, we have the weight. From the weights, so you have your weights in there, which are in grams. Okay, so the weights in grams, you have from 120 less than or equal to W less than 140. You have 140 less or equal to weight less than 150. You have 150 less or equal to the weight less than 160. You have 160 less or equal to the weight less than 170. You have your 170 less or equal to weight less than 180. You have 180 less or equal to weight less or equal to 200. Then you have 200 less or equal to weight less than 210. Now from there, from your table, you have the number of apples. Number of apples. Now this is where you are going to start defining the keywords you are going to use. Now the number of apples, you are going to put in brackets F. such that you can use F going forward. Now, F is standing for frequency. So number of apples is your frequency. So here you have your 6, you have here your 16, you have here your 30, you have here your 36, you have your 29, you have your 2, and you have 1. And when you are drawing your table, make sure that your table is crossed. Now, what do we need? We are going to have our summation of F. So when you add up everything you have here, our summation of F is 120. Now, when you look at what we summarize, we say that we shall need the X. Now here, since they have used weight, I want to first bring to your consideration that I need to first check out what has been given to me. Are they a class or it is already a class boundary? What do you use to determine? I want you look at these values here. You look at those two values there. Now, these two values, whenever you find that those two values are the same, then that is one of the indicators to show you that the adjustment factor is already, we call it the adjustment factor, is what? Is 0. So that means that now, there, you don't need to subtract anything or add. Those already are class boundaries. So I'm going to just come here and now write here my class boundary, the way they are. So when I come here, I'll come and I write that this is 120 to 140. This is 140 to 150. This is 150 to 160. This is 160 to 170. This is 170 to 180. This is 180 to 200. This is 200 to 220. Now, from there, you are going to go on and go on to the next one. The first one was requiring us to find the mid, to find the mid, the X. Now, you know that X, many times for you write midpoint, mid value. But now the data here deals with weight. So you are going to call it mid weight. And now in brackets, you put your X like that. And then you are going to come here and now start. Remember, to get your midweight, it's just a matter of you adding. You can add the class boundaries and divide by 2. But sometimes students, you make mistake. You go to your calculator and you write this, 120 plus 140 divided by 2. And you get everything here wrong. If we are to place it on your calc, dear students, never forget to put brackets. Never forget, because the calculator is going to only divide 140 by 2. So never forget to put the what? Those brackets. So now, when you get the midweight here, you are going to end up here. This is 130. This is 145. This is 155. This is 165. This is 175. This is 190. And then this is 210. Remember, now we are finding the mean. We are going to be finding the mean weight. Now, you know that mean, you need f of x. So I'll have f of x. Now, I can comfortably write f of x because I have already put here f and I've already put x. So I'm going now to come and then I multiply. Multiply your f times x. So 6 times 130, that is what? 780. 16 times 145, that is 2,320. 30 times 155, that is 4,650. 36 times 165, that is 5,940. 29 times 175, that is 5,075. Then 2 times 190, that is 380. And then the last one is 210. Now, after obtaining your values, please indicate here that this is summation of f of x. Add everything. So this is 1, 9, 3, 5, and 5. Now, remember, what else do you need? You need the cumulative frequency. Because there is quartile, so you are going to come here and say now, cumulative frequency in your table, and then after, have your table well closed. So cumulative frequency, I'll have here my 6 plus 16, which is 22, plus 30, which is 52, which is 88, and that is 117, 119, and then 120. Now, this is your table. You have clearly defined all the variables you have used. You have defined, you have added. And I want you always, sometimes some of you forget to put these summations. Please never forget to put the what? The summations. Never forget to write the sigma. This means the sum of f. This means the sum of f of x. Now, after having your table, now defining your variables first, it is okay, but having them on the table becomes very easy for someone scoring your work to see them, because you may define them and someone may not see them. So make sure that the first 2 columns, you have obtained them from your data in the scenario. Make sure that those 2 columns that appear, always the wording aligns with the scenario. Do not create your own words. Make sure that they align with what is within the scenario. Then from here, we are going to go on and calculate our mean weight. So now we are going to come here, obtaining or calculating, you can say obtaining or stroke or calculating the mean weight. So now I'm going to come and say mean weight. Now, some of you always want to represent mean weight. And you know you represent? Some of you want to just come and say mean weight and you put X. Sometimes some of you say M is equal to summation of f of x out of summation f. This is not mean. This is not the symbol for mean. The moment you use it, just know you are gone, because M can stand for gradient. M may mean gradient. So never use symbols you are not sure about. So you write the word mean weight. If you want, we can use that for mean weight is equal to summation of f of x out of summation of f. Now, remember, there is no any score that is given for the formula, but I want you always to write it there, such that you substitute correctly in the formula. So here I'll have 19355 out of 120. So this is going to give us 161 point. Place your calc. 19355 divided by 120 is 161.29167. And remember, what were the weights? These were grams. So I'll write here my grams. But now I'm going to go on and make a conclusion, because that was the first condition. So go back to the scenario. The first condition was, according to the company's quality assurance policy, only consignments with an estimated mean weight of at least 160 grams are accepted for processing. First, make that conclusion. And then you are going to say that since the mean weight of 161 point, I go back, since the mean weight of 161.2916 grams is greater than, so I want you, 161.2916 is greater than the 160 grams. Therefore, it satisfies the quality assurance policy, and therefore the company should go on to process the consignment. Now, when you are making your conclusion, compare the output you have obtained with the condition or the threshold within the scenario. compare the two values, that 161 is greater than, or it is above, or at least above 160. Therefore, what does it mean? That it passes the assurance policy. What should the company go on? The company should accept and go on to accept the consignment for processing. Now, that's how you go on and make such a conclusion. Hope that is clear when it comes to that. Now, what if the width of your answer sheet is not enough? Please, this table never have it discontinued. It should be on the same page. In case your space is small, take it on another page. Never break the page that you are writing here, the first part, and then you are writing here the second part. Never break it. Let it be one complete table. If it means squeezing, squeeze it. I'm not saying the class width, sir. Now, here we do not need the class width. The class width is very important if we were going to deal with histogram, if we are going to deal with mode, that's where we would have needed to have the class width. But here there's nothing like a class width because we don't need it for now. We are still on the first part. So that's how you deal with that. So conclude. In your conclusion, I repeat, conclusion, compare your output. Compare the calculated output. Compare the calculated output with the threshold within the scenario, and then make a decision based on the answer you have obtained. Okay. Okay. So I think we are going to continue. What about when you are given assumed mean? Then there when you are given assumed mean, remember when it comes to assumed mean, for it the formula will be summation of f of d out of summation of f, whereby d is x minus a. Now, never put anything idle on your what? On your table if you are not going to use it. Let everything you put within the table be something very useful that you need. Don't put things in the table that you are not going to use at any point. Whatever thing you put on the table must be useful. If you are not going to use it, don't put it there. Don't put it there. I repeat, anything you are not going to use, don't put it there on your table. Let it be only those things that you need, things that you are going to use for your calculation. That's what you need to put. Okay. We are going to continue. But I want to repeat that in case the class width are not the same, that is basically you have to obtain the frequency density. Please take note that if you find that the frequency, the class width are not the same, then please go on and get the frequency density. Yeah, okay. When do you add and subtract? Now, adding and subtracting only occurs if you have been given classes. And I've said that for you to determine what are you seeing this, we have something we call an adjustment factor. An adjustment factor is given by this upper quartile, which is 140, minus this lower, which is 140, divided by 2. So this answer is 0 out of 2, which is 0. So that's why for it, you don't add or subtract anything. But if this value here is different from this, then that's when you go on and subtract. Hope that is okay. That's when you go on and subtract. I can give an example. Take an example. Now, take an example. If I had something like 10 to 14, and I had another class like 15 to 19, I had another one like 20 to 24. Now, when you look at these two values are not the same. So when you are getting your adjustment factor, you will say 15 minus 14 divided by 2. So this will give you 1 out of 2, which is 0.5. So you can add and subtract 0.5 when you are getting the class boundary. Sometimes if you don't want to use that approach, you use the error approach of 0.5 times 10 power negative n. If you were given 1.2 to 1.4, and maybe you had 1.5 to 1.7, maybe you had 1.8 to 2, and you want to get the class boundary, first check here. As long as these two values are different, for you say 1.5 minus 1.4 divided by 2. So what do you get? This is going to be 0.05. So when you are getting your class boundary, you will add and subtract 0.5. In case, let me say you had this 10 to 15, 15 to 20, 20 to 25. Now, since these two values are the same, when you subtract 15 minus 15 divided by 2, you get 0 out of 2, which is 0. So here, these are already class boundaries. There is nothing you are going to add and subtract. If you had something like 10 less than 20, and maybe this was 20 less than 30, the moment you look at these two values, when they are the same, even if when you are getting that error is 0 out of 2, which is 0. So those ones are already class boundary. If you had something like, let me say, less than 10, less than 20, less than 30. Now, if you are writing these ones as in terms of class boundary, this is 0 to 10. This is 0 to 10. This is 10 to 20. This is 20 to 30. Yeah. Let me hope I have answered. Sometimes they are going to use words like under, below, and the rest of that. That 10 under this, 10 ta like that, like that. So let those words never confuse you. Does the order of the data important? Yes. The order at which you present your data is very important. That's what we call coherence. Make sure that your data flows very well. That you cannot tell us that you are going to find here f and then you are going to find fx and f. No. Let your order of the data flow very well. That start with f, go to x, let us have fx. But don't have fx here, and then here you have f and this side x. No, the order of your data in the table should flow very well. Okay. I think I've showed you when to add 0.5 and when to add 0.05. So we go to the second part. Second part required us to find the lightest grade. So I'm going to come here and let me first draw for you a simple line. Because our data has been divided up to 100, and this one is what I'm going to call the first 25%, and they told that for the first 25%, and then you have the heavy one, so this is also 25%. Now, in between here is where we have the 50% here. This is where we have the 50%. And if this is 25 plus 50, this gives you 75%. So here you have 25%. Here you have 25%. Here you have 75%. And the other side you have 100. So the first thing we are going to obtain, like I've said, we are going to find, because when you read through the item told you that they want you to find the management requires the grading limit and the number of apples in each grade. So you need to know in each grade, what do we have? So I'm going to come here and say, I'm going to first find the number of apples. So I'm going to say number of apples in each grade. In each grade. So I'm going to start with the first one, which you call the economy grade. Economy grade. So the economy grade, for us to get the number of apples, we are going to get the 25%, which is 25 out of 100, then times summation of F. So this is going to be 25 out of 100 times the 120, and this is going to give us 30 apples. Then from there, I'm going to find what about in this, in the next grade. The next grade is the 50%, or if you want, you can first find for the premium grade. Then I will say for premium grade, here I'll say number of apples in the economic grade. Number of apples in the economic grade, we shall have 75 out of 100 times summation of F, which is 75 out of 100 times 120. And this is going to be 75 divided by 100 times 120. Let me hope 75. But now here, this is 25, not in fact 75, because from here in the premium grade is 25, so it's 25 out of 25, which is also 30 apples. Then now, what about in between here? In between here, we have 50%. So that is the, that economy is called the what? The standard grade. For the standard grade, how many apples we have in there? So that one you can either use 50% or you can add the 30 and the 30. So I can say this is 50% out of 100 times 120. So here I'll have my 50 out of 100 times 120, which is going to give me 60 apples. Now, those are the number of apples we have in each of the grades. So, okay. So now after obtaining that, what next? The next thing you are going to obtain is the limit. Now to obtain the limit, you are going to ask yourself, how am I going to obtain the limit for the first 25%? Now that's where your knowledge of the quartile comes in. But I want you always to focus on the language used in the scenario. When you look at the scenario, which language are they using? They are using the grading limits. The grading what? Limits. So here I'm going to say, I'm going to come here and I write grading limits. I'm going to say the grading, maybe I can say weight, something like that. For, I'm going to start with the economic grade for the economy. So I'm going to come here and I say now, what formula am I going to use? I'm going to say the lower plus the summation of F out of 2 minus the cumulative frequency before, everything out of the frequency of the median class, then times the class width. Now, when you look at the economic grade, we found out that the number of apples within this is 30. Now, when I go back, I'm going to come and I look out for 30. So 30 is within here. Remember, when you are looking for that, you consider this. So 30 is within here. So that means that the cumulative frequency before is 52. Now next, I'm going to know what is the class width. Class width, I'm going to subtract here. I will say 160 minus 150, which gives us 10. Because the class width here is 10, then the class boundary, the lower class boundary is 150. What about frequency within this class is 30. Now those are the values I'm going to be substituting in there in the formula. So I'm going to come here and then I substitute accordingly. So here I'm going to come and I will get 150, then plus summation of F out of 2, which was 30, minus 22 out of the frequency within the median class, which is 30, and then times the class width, which is 10. So then I do the math. This is 150, 30 minus 22 is 8. So I'll get 8 out of 30 times my 10. And this is going to give me 152.667 grams. This is for economy class. What does it mean? It means that now any apple they are going to take to be considered for the economy class or for the economy, it should be having a weight of 152.67 or below that. Then what about for the other class? That is for the what? For premium class. So I'll come here and say premium grade is going to be still the same formula, summation of F. However, I want I want to make, this is supposed to be a quarter, not a half. This is supposed to be a quarter. In the formula, this is supposed to be a quarter. Remember, you had 25 out of 100, which is a quarter. Then for the premium is going to be 3 out of 4. Because we are looking at the 75, then minus the cumulative frequency before out of the frequency of the median class times the class width. Now, when you go back to your premium, you ask yourself, for the premium, what did we have? So here I'm going to come and I say the 3/4 of the 120, 3/4 of the 120, what do you get? That here you're going to have 3 divided by 4 times the 120, which is 90. Now, when you come here on your table, you are going to look for 90. 90 is here. So you are going to come and have this. Now, when you have this, what does it mean? Now, here it means that your class 90, in fact, 90 is in the next one. Sorry, 90 is here. This is where we have the 90. Now, you circle. What is your class? It is here. This is the lower class. Frequency of the median class is the 29. The class before is, the cumulative frequency before is 88. Then what about the class boundary? Please, sometimes the class width are different, so you must get for that particular class. So it is 180 minus 170, which is still 10. Now, after obtaining those values, you go back. Where? Here, and then you substitute accordingly. So when we substitute, you note that we had 170 plus 3/4, which is 90, minus 88, divided by the frequency within the median class, which was 29, then times the 10. So when you do the math, you'll have something like 170.6896 grams. Now, when you go back to this kind of scale that I was showing you, that this is 0, and here, now in case I'm to put the weights, I cannot put 0, but instead, when you look at our scale, it started from 120. So that means that here, I can put that this is 120. Here, I have 152.667. Here, I have 170.6896. And here, the last weight from our graph here was 220. 220 if you are to put it there on your gram. So these are the kind of grams. Now, this is the first 25%, this is the 50%, and this is also the 25%. Now, remember, do not confuse that this is 25%, this is 75%, and this is 100%. Now, this was your economy class. This is the economy weight. This is the standard, and this is the premium. Now, if I'm making my conclusion, what do I need to know? Now, you need to take into consideration, they asked you to find the grading limits, a limit. That means that when you are concluding for the economy class, your grading limit is going to be 152.66 grams. When you are talking about standard Standard is going to be between 152.667 here and 170.6896. Anything in between that is going to be called standard. Then anything that is above or equal to 170.6896 is going to be considered to be premium. So those are the limits you are going to give. That for the economic class, they are the ones where the weight is less than or equal to 152.667 grams. Then for the standard, their weight is between 152.667, not inclusive, and 170.6896. Then for premium, they are the ones that are above or equal to 170.6896 grams. So that's how you get their weights. Okay. Hey, why didn't we divide by 4 in the economy class? In the economy class, we have divided by 4. Remember, it is summation of F out of 4. But remember, the percentage was 25 out of 100 times summation of F. So when you do this, you get the 30. That's how we got the 30. Okay, may I ask whether we have any question on this part before we leave? Kindly let me know through the chat whether we are okay. So I take on the first question from DEM. DEM, ask. Okay, Nana, ask.
Yes, good evening, sir. Good afternoon.
Yes, good afternoon.
Yes, sir. I would like you to pardon this. It's like a number line where you're putting the economy.
Okay, you stay on. Nana, what
Yes,
I'm trying
please.
to show you is like is the quartile. That on your quartile, we can divide it into 4 equal parts like that. Is that fine?
Yes.
Now, the first quartile is the one that is 25%. Then the last one is also 25%. Also here is 25%. Also here is 25%. Is that fine?
Yes.
Now,
Yes, sir.
the first 25% is what they called the economy. The last 25%, they called it the premium. Now, this one in the middle is what they have called the standard here.
Yes.
And it represents 25 plus 25, which is 50%. Now, in the books, or when you were studying, your teacher taught you about the lower quartile.
Yes, sir.
And the lower quartile, we told you that always we get 25 out of 100, which is a quarter. So you use a quarter. For the upper quartile is at 75% because 25 plus 25 plus 25 is 75. So 75 out of 100 is 3/4. So in your book, you were using 3/4.
Yes, sir.
So that is what I was trying to show on the number line. That for anything to be premium, its weight should be above the 75%. For something to be standard, it should be between 25 and 75%. Anything below this is what we call the economy class.
Oh, thank you, sir.
Now, Nana, I am going back such that I also answer this. Where are we getting the 120? When you look at your weight, the starting weight is 120. So that's why I put 120. Then the ending weight is 220. So that's why we got them for the lower and then the upper.
Oh.
Okay.
Okay, thank you, sir.
Okay. I thought of using percentile since they were given in percentage. What if you had now using the what? The percentages is very okay since we are given in now the percentages were just given to us to compare. But now when you look at the weights are not in percentile. So you cannot give the weight limit using percentages. So you give it in grams because the weight, its units is in grams, not percentages. So the percentages were just to show us where they lie. Okay, so lastly, Atwine.
Yes, good afternoon, sir.
Yes, good afternoon.
I was inquiring where we started. You say that we start with 120. I'm kindly requesting if you can elaborate more. Like
Okay,
why?
you stay on. Why 120?
Yes, sir.
Like when you look at the limits, when you look at your weight, we got the lower quartile. Lower quartile means something between 0 to 25%. Not so?
Yes. Yes, sir.
Now, from the answer we have got, we obtain our answer for the lower quartile as 152.667 grams. Now, 152 is somewhere here, but the least or the smallest is 120.
I get it.
Okay. Okay.
Okay, thank you, sir. Thank you, sir.
Okay. Okay. Now, someone has asked something that maybe I can throw some little light. When they tell you the middle, was it 60%, something like that. Now, the middle 60%, in case they have asked you about the middle, let me see whether I can do something about it. Now, if you are finding the middle 60%, what do you do? The middle 60% is this one here, between the 20th and the 8th. That's what we call the middle 60% or what. So here, you are going to find out from 0 to 20, what do you have? Then what about from 0 to 80? What do you have? And then the answer you get, you are going to subtract the two answers. That's what we call the middle 60% or whatever thing you want. But also here, I don't want you to get limited that you are supposed to use 20 and 8. As long as the difference between the two gives you a 60, then that one is very, very fine. As long as the thing in between gives you 60, it is also very, very fine. Okay, op aki bua SS, that is okay. When they ask the middle number, it gives 60%. For you, what you need to know that the two values you get here, as long as you subtract the two and you get your 60, it is okay. Another person can decide here, let me use that. But as long as when you subtract the two, you get that, then that's what you can do. So, but at the end of the day, what you need to do is that, what you need to do at the end of the day is for you to ensure that you subtract the 80 and the 20 values you get. So here in your calculation, you say 200, 20 out of 100, summation of F. Here you do say 80 out of 100, summation of F. Then you subtract the two. That's what we call the middle value. Okay, allow me, I think the questions are many. Can I obtain the 60 and 80%? Yes, you can obtain them using the what? Using the same way you calculate using the 25% is the same way you calculate using the 60 or the 80%. Okay. Okay, I'm going to go back now to the second item, to the second part. Now, when you look at the second part, here, I'm going to keep this and I want to take it, here. So we are going to go to the second part. The second part told us that the packaged apples are transported daily to the processing plant. Historical records show that the probabilities of sunny, rainy, and stormy weather during transportation are half, a third, and 1 out of 6, respectively. The corresponding probabilities that a delivery truck arrives on time under these weather conditions are those. Now, what does it mean? What does it mean? When you meet the probabilities, dear students, have those probabilities summarized. Clearly define what you are using for. Clearly define what you are using. Clearly define what you are using. That I'm using sunny using this letter. I'm using this because of this. So the first thing I'm going to write is going to be my summary. I'm going to summarize my probabilities. So I'm going to say, I'm going to write here that probability of S is the probability. It is the probability of, now from the question, they told you probability of sunny. Then I'll write maybe which other letter I can use R to represent probability of rainy. Probability of rainy. For the weather to be rainy. Then I can use T to mean probability. This is probability of what? Of storming. Now, after you defining them, you can now extract. Learn always to extract your data. Extract your data from the scenario and write it in figures. So I'm going to come here and say, now my probability, when you check here, this is our probability for sunny. Here I have. This is for rainy and this is for stormy. So I'm going to come here and write probability of sunny is from the item is going to be a half. Probability of rain is going to be a third. Probability of stormy is going to be 1 out of 6. You summarize your data. You summarize your data. Then from there, I'm going to continue. They went on and said that the corresponding probabilities that a delivery truck arrives on time under these conditions are 4 out of 5, 2 out of 5, and 1 out of 10. Now, whenever you find probabilities whereby one probability occurs and the other comes in, then just know that you are going to be dealing with conditional probabilities. That if for when it is rainy, something, the delivery truck will arrive on time. Now, those two probabilities is what is going to bring in our conditional probabilities. That's why we have the Bayes theorem. Now, I'm going to come and say that now, when you find such, you have two conditions. You have sunny, and you have time, arriving on time. Now, this is what we call conditional probabilities. Now, when you are looking at conditional probabilities, dear students, be very observant. Sometimes I love putting it like on a diagram like this, whereby what I put down is what has already occurred. Has already occurred. This is the probability that for something that has already occurred. Then, this is what has not occurred. Has not occurred. or something that is going to occur, it's going to occur is what you put up. What you put up is what is going to occur. What you put down is what has already occurred. Now, I'm going to first, when you look at our scenario, I'm going to say that because they are talking about a delivery truck arriving late, and this is arriving on time. Now, if I want to get, if I'm going to represent L, let L, probability of L, be a truck arriving late. Arriving, a probability of truck arriving late. Now, when you look at our scenario, they gave us the probability when it is arriving on time. Now, how do you write them mathematically? Now, this is what I'm saying. What has already occurred is that the day has already been sunny. The day has already been rainy. The day has already been stormy. Now you are finding out, what about it becoming late when the day is sunny? What is it when the day is? So what you put down is what has already occurred. Now, for the truck to arrive late, it is dependent on sunny, rainy, or stormy. Now, what am I going to write? I want to write the probability because the sun has already occurred. I will put it down. What has not yet occurred is for the truck to arrive. So I'm going to say the probability that the truck is late given that it is sunny. Sunny has already occurred, but late has not yet happened. So now I'm going to say that now this one is going to be 1 minus 4 out of 5. So here I'm going to end up with 1 out of 5. Then I'm going to say probability that my truck is late, given that it is raining, is going to be 1 minus 2 out of 5. And this is going to be 3 out of 5. Then the probability that it is late, given it is stormy, is going to be 1 minus 1 out of 10. And this is going to be 9 out of 10. I want you to please check out how I'm summarizing. Because in the item, they told us it is arriving on time. But when you look at the item, our item is looking at us arriving what? Late. Now, for us to get on arriving late, it means that I get 1 minus it arriving on time. Kindly let me know through the chat, those who can type, whether we are on the same page on that. Remember, I'm still summarizing my data. Kindly let me know whether you have understood that. Okay, have you understood that? Why we are subtracting? In the scenario has given us arriving on time. But now I want to know what I want to repeat. When you read through the scenario has told you that the delivery truck arrives on time under these weather conditions. This first one is sunny. This next one is rainy. This is stormy. Now, I would have written probability for it arriving on time, given it is sunny. This one is given by 4 out of 5. Probability that it arrives on time, given it is rainy, is 2 out of 5. Probability that it arrives on time, given that it is stormy. Now this one becomes a challenge. It is 1 out of 10. But since the item is focusing on arriving on late, that's why I will say that for it to arrive late, given it is sunny, you say 1 minus 4 out of 5. For it arriving late, given it is rainy, is 1 minus 2 out of 5. For it arriving late, given it is stormy, is 1 minus 1 out of 10. So that is what we are doing for us to get in there. Now, after obtaining those different conditions for the different probabilities, I want to repeat that for the event that has not already occurred is what is always up. Then the one that has already occurred is one that you put it down. That is what we call the given probabilities. Yeah. Hope now it is okay. Kindly let me know whether you have understood the two explanations. Let me know through the chat whether now it is fine. Were we going to still subtract? Yes. Okay, members are saying now it is okay. Now, after that, we are going to continue. I can as well summarize it on the chart. Let me summarize it here. That you, dear students, you have three conditions. You have sunny, you have, let me say this is rainy, and this is stormy. Now, you want to find out what are the chances that this vehicle arrives late, so it can either be late or arrive on time. It can either be late or arrive on time. It can either be late or arrive on time. But what the question has given you arriving on time. They have given you here arriving on time. So to get late, you have to say 1 minus. They have given you arriving on time. Arriving on time here, they gave you, for stormy, they gave you 1 out of 10. Here for arriving, no, this is time, given it is raining. They gave you 2 out of what? 5. Here they gave you 1 out of 10. Here they gave you 4 out of 5. So to get this one of late, you just say 1 minus. To get this one of late, you do like that. So what is the next? We need to first find out what are the chances that the vehicle is going to arrive late under all the three conditions. So for us to find that it's going to arrive late, what do you need to do? We are going to be combining. I'm using now this Venn diagram tree. I'm going to be combining sunny and it is late, rainy and it is late, and then stormy and it is late. Now that is the probability of late. So I'm going to come now here. Allow me to come here and then I will combine. So I'm going to say the probability that the truck arrives late is going to be the probability of sunny late plus the probability rainy late plus the probability of stormy and it is late. But you know, from your condition probabilities, from your definitions of condition probabilities, what do you remember? That if, dear students, I have the probability of L on a sunny day, you know, by definition, this is L intersection S out of probability of S. Now, if I have probability of L intersection S, you know that this is probability late given S times probability of S. You know that very well. So now here, we are going to substitute that this is the same as probability of L, it is late given sunny times probability of our S, plus the probability of late given it is R, then times probability of our R, then plus the probability of late given T, then times probability of our T. Then from our summary, you remember very well, we say that probability of S is a half, of late given S is 1 out of 5. So here we are going to say this is 1 out of 5 times our half, plus this is a third times the 3 out of 5, then plus 1 out of 6 times 9 out of 10. So this is going to give us 1 out of 10. This is going to give us 1 out of 5. And this is what? 3 out of 20. So at the end of the day, this is going to be 0.5. And now those are the chances that our truck is going to be late. The tree diagram, I've just used it to summarize for you what we are doing, but it's not needed. Now, this is the probability that the truck is going to be late. Now, after obtaining that the truck is going to be late, go back to the scenario. What does the scenario say? According to the company's transport policy, additional refreshed truck will only be purchased if the probability that the delay occurred. Now, that's where the math is. That the delay occurred during stormy weather exceeds 40%. Now, this is where you need to understand. Now, here, I told that for the event that has already occurred, you put it down. So this is late. That now this, what are they saying? That the truck is already late. But it being late, they are saying that it was because it was stormy. Now stormy comes up. So now here you are going to write the probability that it is stormy given the probability of stormy, the probability of stormy given it is late. Have you understood that? Kindly let me know through the chat. They have told that the truck, because they have told that the truck is already late, but they are claiming that it is because it is stormy. So when we are writing it in condition probabilities, the event that has already occurred is what is put down. It is already late, but it is because it is stormy. Have you understood that? I repeat, from this they have told that if the probability the delay occurred during stormy weather, because they have told that last week one truck arrived late, the truck is already late. That is it here. But they are saying, what are the chances that that truck was late because it was stormy? Now, for the event that has already occurred is what you put down. The event that has not yet happened, or that is occurring, or what you are suspecting is always put up. Now, the question indirectly wanted us to find the probability that is stormy given it is late. So that is what we are going to be finding out. So we are going now to come here in our probabilities and then say the probability that the day was stormy given it was late. So this is by definition the same as T given L out of L. But you know from your math that probability of T, L can be given as, or can be written as L given T then times probability of T. So where there is T intersection L, we are going to write it as L given T times probability of T, everything out of probability of L. Now, what is L given T? That one we had it as 9 out of 10. Probability of T is 1 out of 6. Probability of it, the truck coming late, was 0.45. So here we have 0.45. So now we place our calculators. 9 divided by 10 times 1 out of, 9 divided by 10 times 1 out of 6 is 0.15. 0.15 out of 0.45. Divide by 0.45, and here I'm getting the answer as 1 out of 3. Now that is the probability. But remember, they told you that for this particular probability, they are looking at it whether it exceeds 40%. Now here they gave you in percent. So you are going to write your probability also in percent. So here in percentage, we shall say a third times 100. And a third times 100 gives us 33.3333%. Now, you are going to conclude basing on this. Now, when you look at the percentage that this truck was late because it was stormy is 33.33%. So I'm going to go back to the scenario. And then what am I going to say? I'm going to say that since the probability of 33.33% is less than the 40%, what is going to happen? They told that according to the policy, additionally freighted truck will only be purchased if the probability that the delay occurred during stormy weather exceeds 40. Now, when you look at exceeds means it is greater than 40. But since it is below 40%, then we do not need to purchase a new refrigerated truck because 33.3% is less than the 40%. So that's how you can make that conclusion. Okay, so let me first pick some questions. Yes, top times.
Yes, good afternoon, sir.
Yes, good afternoon.
I would like to inquire on the expansion of where we have let that probability of the track being laid, where I have expanded it in such a way that it is probability of T intersection L over probability of L, and then we have further expanded it
Where? At this
on
step
that slide, yeah, on this slide,
here.
letting the, yes,
Now you have understood this step.
yes, for that I've understood. Now what I'm
Uh-huh.
asking, why is it
Okay,
that here
now
when we are
from
getting
your
that?
math, are you seeing
Yes,
this from your
yes,
math?
yes,
You know that this is the same as L intersection T, true?
yes,
Divide
yes,
by probability of T. Is that fine?
yes, it is.
So when you cross multiply, or when you multiply both sides by probability of T by probability of T, is
Yes,
that fine?
yes,
You get probability of T times probability of L given T is equal to probability of L intersection T. Is that fine?
yes.
Now, where there is T intersection L is where we are substituting this.
Yeah, I'm getting.
Okay. Is it fine now?
Yes, thank you.
Okay. Nana?
Yes, sir. Thanks for the opportunity. Sir, here I've understood, but again, isn't there in circumstance that would appear when I don't have to make this the subject, but when I have, let me say, the value of T and L, and then T has to cancel.
Oh, now that one can occur. That one can as well occur depending on what you have been given in the scenario. It depends on what you have been given in the scenario. But that one can occur depending on what has been given in scenario. But now that case you are talking about is a special case. And now that one is a special case, and that case only occurs. That case will only occur when we have what we call mutually exclusive events. Hope that is okay.
Yes, sir. Thank you.
Or when you
So
have,
when
and for mutually exclusive, then for it, the intersection, in fact, you'll get 0. But also when the events are independent, when the
yes,
events, let me say, they tell you that in case you discover that maybe the events were independent, then that one also you'll find those things canceling, because when you expand and maybe you find that they were independent, you'll find that they are going to cancel a bit, that this and this will cancel.
okay.
Yeah, but always ensure you have interpreted the scenario very, very well, because this is
Okay, thank you,
application of the Bayes
sir.
theorem.
Okay, thank you, sir.
Okay. 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 So I think uh, we are going to first hope this is okay. This is okay. Now, what do I want to emphasize? I want to emphasize that number one, always have your subtitles in there. Don't forget to put the what? The subtitles. Then number two, I want you always to have your probabilities. Show your probabilities. Never forget to show your probabilities or assume something. So always show your probabilities and show your working very clearly. Don't jump steps here and here, there and there, and so on. Now, where do you state your Bayes theorem? Now, at this point here, I can come and say, now applying the Bayes theorem here at this point here. Because this is where now you have reached. Because when you look at this condition, that condition is the one that brings in the Bayes' what? Theorem. Now state it at this point that this is Bayes' theorem, and then continue doing your work. So here you could say the probability, the total probability of someone being, the total probability of late, of the truck being late. Yeah, so that is how you do it. Hope that is very, very fine. So hope Matia hope Matia Mlomba, you have seen where okay. So I think that is okay. Allow me now to first stop sharing, and then we do, I think I've answered the questions people had. I think I'm going to do one more item, and then we can call it there. So I'm going to share my screen again. And then I say that, and then we do at least one more item. We have not done anything from mechanics, so allow me to do something from mechanics. But before we dig into mechanics, allow me to first do something on that item, or on that branch of data and probability. Now, dear students, when you are dealing with the data, kindly take note that the competence will require you to be able to analyze the data through collection, presentation, and evaluation of the different parameters. So what are some of the things you need to know? When you are approaching any descriptive statistics number, please take note that you know how to calculate mean, mode, and median. Pay attention to the language used. Sometimes they can use mean weight, stick to mean weight. They can use average, stick to average. They can use modest, still stick to modest. So always read the scenario, ask yourself, which language are they using in the scenario? Don't create your own language. For you, check on the language used in the scenario and then stick on that language. Sometimes they can use the dominant mark. Now, when they use the word dominant mark, dominant weight, you need to know that dominant, that means what? There is something I'm going to check out, that is mode. So you need to always look at the language used and then you stick to that. Median, know when they bring in the median. The moment you check out and see things concerning percentage, then you need to know that it is about percentage. Then if it is about percentage, then you need to know that, hey, then there is something concerning cumulative frequency curve, or that is in case that is the direction, but now that means that I will need cumulative frequency in my calculation. Know something concerning percentiles and the deciles. When it comes to the graphs, know when do you draw the ogive? Under what conditions and how do I draw the ogive? When you are drawing the ogive, I do not expect you to put your class boundary. If the question has used weight, put here the weight. If they have used, instead of frequency, put the number of people, number of weight, number of apples, and the rest of that. Have a title where need be have even a scale. Make sure that your curve starts from here and then have it drawn smoothly. In case you are estimating anything, please show that now this is the estimation. Don't just read from the graph without showing these lines that show the estimation of something. Always indicate the estimation marks that now I'm estimating something from the graph. Know that when you are dealing with the histogram, sometimes always you have to check, are the class width equal or they are unequal? Where the class width are equal, know that now that is very okay. I'm going to be plotting my frequencies against the class boundaries. But for the cases where you are going to meet that the class width are not the same when you are drawing the histogram, please take note that then there you need to have what you call the frequency density. And when you are drawing the frequency density, then you need to know, how do I get the frequency density? That I'll have to get my frequency against the class width. Please take note of that. take note. Sometimes even they can tell you to superimpose maybe a frequency polygon. Please take note of that. And just know that when you are using a histogram, mainly a histogram is used for estimating the mode. And when you are drawing for class width that are not equal or for unequal class width, please take note that your scale should be uniform. Some of you have do not observe that. You find that you have drawn the class width are not the same, but you have come down here and here you have used the scale here. You have 20, 30, 40. And for you, instead of maintaining a uniform scale, your scale is different. Whenever you find that the class width is different, make sure that along the horizontal, you use a uniform scale. Use a uniform scale. Don't copy that data directly from the table and put it here. You are going to get wrong things. Always first ensure that the width you are using. Create your own class width. Create here such that you are uniform. Yes. So that one, please take note on that. Okay, now that one, please take note of that. Know that when it comes to estimations, we mainly estimate the mode, median, quartile, deciles, percentiles. Yeah, and at worst, if something happened, they can tell you to estimate median on a histogram. That is at worst, but that one you can make your research. Now, what are some of the causes for students to fail some of these things? One of them, some of you forget to write a title. You fail to tell us which kind of presentations are you using. Label your presentation columns very well. From the scenario, always label basing on what you have in the scenario. Don't put irrelevant columns. Now, like someone was asking, well, I'm not seeing the class width, but do you need the class width in there? Have you been asked to draw a histogram such that you have it? You don't need it there. So don't put irrelevant things and never put constant data there. Data, let me say class width is 10, and then you put 10, 10, 10. It's not needed there. Don't put irrelevant columns there. And sometimes some of you don't know how to draw an ogive. You don't know how to start an ogive. Some of you draw your things and then you have your graph like this. Your graph has no starting point, has not started from anywhere. This is a wrong graph. Please know how to draw an ogive, that it must start from here and then it goes. I always tell students that in case your first starting class is maybe 9.5 to some, start from this lowest class here and name it 9.5 and then continue. When it comes to a histogram, know that when the class width are the same, here your bars are going to be the same what? The same size. When the class width is different, you'll find that your bars are totally different. And sometimes you may find a number where you are going to need to find a bimodal, whereby you have drawn your graph, but when you look at your graph, you have two bars that are at the same what? At the same level. So for such cases, please read the two modes, that you have this as your first mode, and then you have this. As long as these bars are at the same level, you can have a bimodal on your graph. So read both modes. Don't say that, now let me read one. Now, interpret the language being used in the scenario. And like I've said that your columns, the first two columns must always match with the scenario. Then some of you don't know how to write formulas and symbols. Some of you, I want to warn you that some of you have adopted letters. For you, the way you want is the way you describe the letters. Someone is writing the mean, and you know how he writes? He's going to write mean, and someone write M. Please, M doesn't stand for the mean. Someone is writing maybe variance. Instead of writing something like this, someone comes and writes his own symbol, maybe val. Don't write this kind of thing. If you don't know, write the word variance and maybe a standard deviation and the rest of that. If you are not sure about those words, please, if you are not sure about the symbols, please do not commit yourself to writing things you are not sure about. Don't commit. You'd rather write it in words and complete the word variance, standard deviation, what and what, without abbreviating. Don't abbreviate things you are not sure about. Don't write symbols you are not sure about, because that one at the end of the day, it's going to keep on costing you. Don't commit yourself to symbols you are not sure about. Only write things you are sure about. In case, God forbid, because of anxiety, you have forgotten the symbols for, let me say, mean. Remember now, I want to tell you that this, for mean, when you are writing mean, for mean we define it like that. If I'm writing mod doesn't have a symbol, so I write the word mod. So don't write M. This is not correct. Don't say, maybe M or D. Don't write those kind of what? Kind of symbol. Median doesn't have a symbol. Write the word median. Do not abbreviate things you are not sure about. In case I'm writing variance, I know variance. If you don't know the symbol that it is written like this, do not commit yourself. Standard deviation, we write it like this. Don't say SD. What does SD mean? Don't write symbols you are not sure about. Some of you want S.D. This doesn't mean standard deviation. This is something different, even we don't know. So please stick to the language that you know. Write standard deviation, write mod, write median, and the rest of that. Don't commit yourself to symbols that are not there mathematically. Then please check out the scale. Most of our class boundaries, when they have given you a scale that is not uniform, please make sure that the scale you have in between here is consistent, is the same. Some of you fail because the scale is wrong. And whenever the scale is read from here and is wrong, the examiners do not have your time. They'll just move on and you lose out. So please check that the scale you are using on any graph is consistent and is uniform. That one will make you have the correct things. Now, which areas do they look out for? Now, when they are looking out for what to mark, they are going to look at your table. Do you have the method of presentation? That yes. Have you labeled your classes and columns very well? Yes. How is your classes? For data that is grouped, we expect that your class width, your class width between the data is consistent. Because here and here I want to bring to your attention, I'm going to talk about it. Then in case there is involves tallying, you have tallied your data very well. Then make sure that you have relevant analysis columns. Don't just write anything on your graph. Things that you don't need, for you have included them there. Anything you are not going to use, don't put it there on your table. Then some of you forget to put the sums down there. These things are scored. They are very important. You put the sum of f, summation of fx, summation of fx what? Squared. When it comes to the formula, please list the values to be substituted. Write the formula in there, but please make sure that the symbols for the formulas are the correct symbols. If it is mean, if it is standard deviation, if it is variance, if you don't know, write the word in there. But remember, when they are scoring for the formula, they look at correct values in the correct formula. That's when you are going to be awarded the score. And they look at the output, the answer. Where units are needed, put the units there. Do not forget the units. When it comes to the graph, specify the curve, that it is a histogram, that it is an ogive, it is a cumulative frequency graph. Ensure that the scale on your graph is consistent, is the same, both on vertical and on the horizontal. It doesn't mean that the scale should be the same, but I am talking about consistency, that if you have used the scale of 555, stick to 555. If along maybe the vertical, don't say here 5, here 10, 15, 20. That is wrong. Estimate the values. Show the estimation values on your scale and write your response very, very well. Once you do that, you will be able to get the values very well, and you'll be able to get the maximum values or the maximum scores on that item. So please take note of that as you are responding to the item. Allow me now that now I switch you and we do one item at least from the mechanics side. One item from the mechanics side, and then we see how to go about that. I want to switch to mechanics. Mechanics is which item? Mechanics is item 16, 17. Okay, I'm seeing a hand up. I'm seeing a hand up. You get to your pamphlets and we go to item 16. Student, you may ask.
My question is, I want to clarify more on drawing the histogram when you get two highest bars of the same height. How do you get the mode using that graph of histogram when you have bars of the same height?
Yes, I have talked about it. I've said that in case this is your bar and this is your second bar and maybe this is your second bar and this is the bar. Here it means that you are going to get two modes. We call it bimodal. So what you do, come here, you draw like this. Come here, you draw like this. Read off this mode. Come here, do like this. Now, for this one, in case maybe it is the last one, then I'll just expect you to come and then you draw something like that. Then you read off that value. In case, let me say the bars are joined. The bar and the bar are together. Now, for this one, please take note. This is still bimodal because these are two modes. Come here, do like this. 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 Read off this mode, read off that mode. Hope that is okay.
Okay, meaning you don't get their sum and divide it by 2, just to get them separated.
Yes, separated. That one shows you that you have two highest values.
Okay, thank you so much.
Yes. Okay, now we can switch to item 16. Let me hope you have gone to your item 16. Okay, now item 16 told us that a golf training academy is evaluating a new practice range before introducing for professional training. What does it mean? Some of you, I don't know whether you know golf. Golf is a game that is mainly played by what? By some, I wouldn't want to say rich people, but mainly it is played by those people that maybe have time, but it is a game. It is a game that is usually practiced by different people, and it is a good game. I know some of you know it, some of you have not yet maybe played it, but it is a game that someone can play and then you enjoy. So I'm still continuing. Like I said, that always you are going to first highlight the mathematics. You are going to highlight the mathematics in there. Now, when you come here, highlight the math. When a particular shot is struck from a raised platform, highlight that math. From a raised platform. Then from there, you are going to say that which is 4.9 meters above the level of the field. The golf ball leaves the club with a speed, highlight all the math, at an angle of elevation of alpha, highlight the math, 98 meters horizontally from A. The motion of the golf is modeled as a particle moving free under gravity, neglecting air resistance. Then they have given you some threshold conditions. Now, that is the math we are going to do. Now, when you look at this, you are noticing that here, the topic being assessed, if I may ask, put for me in the chat, which topic is this in dynamics? Which topic is this? For those who can type, very good. It is projectiles. Now, that is the concept. We said yesterday, I told that always identify the concept in the scenario. Identify that concept in the scenario. After identifying the concept, then go on. Where need be, please make a sketch. Make a good sketch for your work, for mechanics, for many of these things where you can make the sketch, come up with a sketch. Now, those who don't know golf is a game of that nature. And always they're aiming at making sure that this ball here hits in there. Now, what do they want? They want us to determine whether the proposed launch technique satisfies the academy's training requirements. And what are the requirements? Requirements are here that the golf must remain in flight for not more than 2.1. The maximum height, the golf does not exceed 30 meters. Now, those are the conditions that you need to know or that needs to be satisfied. Now, what am I going to say? Like I've said, always have subtitles. Show the examiner, show the person looking at your work, what are you doing? Number 2, identify what problem are you solving within the scenario. So I'm going to come here. I'm going to come here and then I start working out my item. So when I start working out, I'm going to start with a sketch. Have a simple sketch that shows what you are doing. Then after having that simple sketch, then you go on and make the calculation. So here, like I've said, identify the concept, which is going to be projectiles. Projectile on a raised cliff. I can put something like that. So I'm going to come, I make my simple sketch, and then this is my projectile. Okay, now after making my sketch, please always use the things being used in the scenario. So I'm going to come here. You know that we have speed that has been given as 49 meters per second. I'm going to come here and I do like this. This is the angle of projection, which they have given us as alpha. Then this is the horizontal, this is the ground. In here, they have given us 4.9 meters. Here, they have given us 98 meters. Now that is the first thing I need to write. Now that is my sketch that I've come up with. Now, here, after coming up with your sketch, you need to know the horizontal motion and then the vertical motion. So I'm going to first summarize about the horizontal motion. Now, for my horizontal motion, in case you are going to use some letters, define the letters. You know that along the horizontal motion, your acceleration due to gravity is always 0 meters per second squared. Now, you know that the displacement, horizontal what? Displacement, which I'm going to call x, is given by, when you resolve, is given by u cos of theta, then times t. But like I've said, for letters you are going to use, you define them. So I'm going to come here and say that t is the time in air, or I will say the time of light. That is my t. Now, I know very well from my equations of motion that always s is given by ut plus a half of at squared. But since our body is going up, we know that s is always given by ut plus a half of gt squared. Now, for horizontal motion, we know that g is 0, but I know I can find s, which I've called x as my displacement, is going to be u cos, but please never use theta if the question has used alpha. So I'm going to change this to cos of alpha. T is the time. Now, this is my horizontal distance here. This one here is my horizontal distance. But we have said g is 0, so I'm going to have this as 98 equaling to u, which is 49 cos of alpha times t. And this is going to be my first equation. Then for vertical motion, still my displacement s For vertical displacement, I will come here and say vertical displacement. For my vertical displacement, which I'm going to call y, my y is going to be u sine of alpha t. Since I've thrown the body up, or the body is going up, is going to be negative because it is opposing gravity. Then why we are using sine is that when you resolve this velocity here around this, it becomes u sine of alpha. When you resolve it horizontally, it becomes u cos of alpha. That's why for horizontal distance, we use cos. For vertical, we use sine. So when we substitute here, our y is 4.9 is the vertical distance. But because it is below the point of projection, it's going to be negative. Whenever your distance is below the point of projection, you take it as negative 4.9, our u, which is 49 sine of alpha t minus a half times. Now, to get your g, always look at the question paper. The question paper will always tell you what your g is. So here I'm going to use 9.8 times t squared. So here I'll have negative 4.9 is equal to 49 sine of alpha t minus 4.9 t squared. And this is my second equation. Kindly let me know through the chat whether we are on the same page, whether you have understood those two equations for the vertical motion and then for horizontal motion. Okay, kindly let me know through the chat whether we have understood. Let me ask Bruce, unmute.
Yeah.
You may ask.
My question is where
Come again, where? Okay, your network is not good. Kindly type in the chat. Your network is not good. Okay. Okay, I want to throw more light again. Now, you know that we have basically three equations of motion. V is equal to UA plus T, S is equal to UT plus a half of AT squared, and then we have V squared is equal to U squared plus 2AS. Now, these equations of motion work when you have mainly horizontal motion. Now, since since for projectiles something is thrown up, acceleration is due to gravity. So A is G. Here you consider G, and here you consider G. Secondly, whenever you throw something up, it is opposing gravity. So your G is always considered negative because it is opposing gravity. Now, if you are considering something horizontally, something moving horizontally, it will never have G because acceleration due to gravity is always up and down. So it means that this equation S is equal to UT plus a half of GT squared. The whole of this one comes 0. Because G is 0, so you remain with S is equal to UT. Anything moving horizontally. Then number 3, I hope that is okay. When you look at our velocity, this is 49, and here you have alpha. Now to get this velocity horizontally, this is your y, this is your x. Now your y is along the opposite. This is along the adjacent. So you know that sine of alpha is given by opposite out of hypotenuse. So it means that sine of alpha is opposite, which is y, divide by hypotenuse, which is your velocity, which is 49. So when you multiply through, you get 49 sine of alpha. Now, the vertical component for velocity is 49 sine alpha. That's why anything vertically, we shall use 49 sine alpha. Then horizontally, it is cos. Cos alpha is adjacent, which is x, out of our hypotenuse, which is 49. When you cross multiply, you get 49. Cos of alpha is equal to x. That's why we are using our x as 49 cos alpha, because it is horizontally. So for anything horizontal, for horizontal distance, we have said acceleration due to gravity is 0. But this initial velocity, when you resolve it, you get cos. That's why we are using cos. For vertical, we are using sine, because when you resolve it, you get sine. Let me hope now it is okay. We don't use g as a positive, because acceleration, you are opposing. We are opposing. So whenever you are opposing something, we use. Then capital T is the time the particle is going to take to move from the initial point to where it lands. So here it's landing at point B. So that's why we are doing it like that. Hope we are on the same page now. Now, when it lands, accelerate, like, remember here we are looking at the initial motion of the body. Initially, when the body is projected, is going upwards. So what pulls it to come down is the acceleration due to gravity. But when you throw it up, it is opposing. So we consider the initial velocity, the initial acceleration, which was taking the body upwards. Why didn't we use negative 4.9? It is negative. No, then this is the negative. You are seeing negative here. This negative has come in because G is our opposing gravity. So that's why it is G. Okay, let me pick one hand. TTC ask and Saint Matia Mulumba ask.
Yeah, master.
Yes.
Why are we using negative 4.9?
Negative 4.9 is coming from here. Did you understand this step here?
Yes, sir.
Yes, so 9.8 divided by 2. What do you get from your calc? 9.8 divided by 2. Have you understood?
Yes.
Okay. Oh, you are talking about this negative maybe. Now
I'm talking about that.
This one. Now, this is the vertical displacement of the particle. Now, this one, because it is below the point of projection, we consider it as negative. Negative means it is below the point of projection. Is that okay?
Yes, sir.
Okay. Alinga, SS. Okay, I failed to get Alinga, and I'm failing TTC.
Yes. Good evening, sir.
Yes, good evening.
Actually, my concern is, what if I use the equation of trajectory and I obtain the angle alpha, then after obtaining, I go back to the formula of calculating the time of flight and I find that time. Is it also necessary?
Yes, I want to say it is okay. However, it also comes with its challenges. Number one, it requires a child to cram it. Number two, in case of any mistake, everything becomes wrong. Of which now here, a step-by-step approach, you go on getting some scores when you are responding. Have you understood? Okay. When you use a step-by-step approach, you can get some scores. But the moment you use a formula, you'll find that the formula, in case of any errors, in case of any mistake within the formula, everything becomes wrong. But always I want you to learn how to come up with things step by step without basing on the formulas. Okay? Hope it is okay, TTC. Zubi? Okay. Nana? This TTC?
Teacher,
Wange? Yes, hello?
Yes, please.
Yes, sir, I've understood.
Okay.
I've
Nana?
understood the...
Okay.
yes, teacher. So
Yes,
I was
please.
inquiring that, okay, like in this question, they're telling us that one particular shot is struck from a raised platform A, and that's why we draw a sketch like that. But there are some circumstances we find that this angle starts from the origin. So I was inquiring, like, which statements do they use, like when this angle is starting from the ground exactly?
Okay, I'm going to give you, one of it is like when they tell you that a football player kicked the ball, something like that. Now you know that the ball was kicked from the ground, but I'm going to give you some scenarios at the end of this item.
Okay, thank you, sir.
Okay, now after this, members, now we have two equations that we are going to work out. So the first equation we had was this one of 98. So we had 98 was equal to 49 cos of alpha t. Now you can simplify this by saying 98 out of 49 equals to cos alpha t. And when you go on and divide 98 divided by 49, you end up with t equals to cos of alpha t. Then the second equation that we had obtained was negative 4.9 was equal to 98 sin, was it 98? No? Okay. Let me first erase this. The second equation that we had negative 4.9 equals to 49 sine of alpha t minus 4.9 t squared. Now what you are going to do, you are going to make one the subject of the formula and substitute. So from here I can say that 2 out of cos of alpha is equal to t, such that I come in this equation where there is t, I substitute. So I'll have negative 4.9 equals to 49 sine of alpha times t, which is 2 cos of alpha minus 4.9 t squared, which is 2 out of cos of alpha, everything squared. So this is going to give us negative 4.9. 49 times 2 will give us our 98. Sine out of cos gives us our tan of alpha minus 4.9 times 4 out of cos of squared alpha. Now at this point here, you can write this as negative 4.9 equals to 98 tan of alpha minus 4.9 times 4 is the same as 19.6. Then from your math, you remember that 1 out of cos squared theta, alpha is the same as sec squared alpha. So where there is here is what I'm going to replace. So this one, I'm going to write it as sec squared alpha. Now from that point, I'll have negative 4.9 equals to 98 tan of alpha minus 19.6. Sec is the same as 1 plus tan squared of alpha. So when you open the brackets, you have negative 4.9 equals to 98 tan of alpha minus 19.6 minus 19.6 tan squared of alpha. So what are you going to do? You are going to arrange it in a good order. So I can have 19.6 tan squared alpha minus 98 tan of alpha minus 4.9 plus 19.6 is equal to 0. So you form your quadratic equation as 19.6 tan squared alpha minus 98 tan of alpha. Then this is what? This is 14.7 equals to 0. Now this is a quadratic equation. So you can bring in your bulldozer you can bring in whatever thing. So now I can write this in a bulldozer form as tan alpha is equal to negative b plus minus into b squared minus 4asc out of 2 of a. Then I substitute that this is negative b, which is negative 9.8. Sorry, it is 98. 98 plus minus negative 98 squared minus 4 times a, which is 19.6, then times c, which is 14.7. Everything divided by 2 times a, which is 19.6. So I'm going to ask you to do your math. Here I'm going to get 98 plus minus. Do your math here now. I'm going to summarize, but for you do the math. Times CCC 14. Do the math, and then we shall compare. Do the math. Do the math, and then we'll see what you come up with. Do the math. Then you can tell me what you are coming up with through the chat. Here I'm getting 845. 1.52 out of 2 times 19.6. So you do the math. Do the math. I'm also doing the math, and then we get the value. Do the math. Do the math. Okay, hope we are doing the math. I'm also doing the math, and I want to let you know that the first value I'm obtaining from my calculation, I'm getting tan of alpha equaling to 4.84520788, or I'm getting 0.1547912. I'm getting those two values. Kindly confirm. Okay, very good. Very good. Okay, now from here, we are going to take on our alpha. So we shall say that now alpha is tan inverse of 4.84520788. And from my calculator, I'm getting something tan inverse of that. I'm getting 78.338 for 9 degrees. And then the second alpha, I'm getting 8.7999101 degrees. Now, after obtaining the values of alpha, what did the question want us? We need to find the time. So you remember, we obtained that our time was 2 out of cos of alpha. You remember very well from this equation here, we had from this equation star. So we are going to use that one to find the time of flight. So this is going to be 2 out of cos of 78.33849. Then another one is going to be t is equal to t out of cos of 8.7999101. So when you place your calc, I'm getting for this one, cos of that, then 2 divided by this. Here I'm getting 9.89465 seconds. Then for this second one, I'm getting my answer as 2.0238 seconds. Now, after obtaining those two answers, that is the time the particle takes to follow on the ground. Now, you are going to ask yourself, on those two, which one would be the best? Because they told you from the scenario, the golf remains in flight for not more than 2.1 seconds. And when you look at the answers we have obtained 2.02, and also we have obtained 9.894. But one of the suitable condition is that it should not remain in more than 2.1. Now, when you look at the two answers, let me know through the chat, which answer are you going to consider? Which answer are you considering? You have those two times. Which answer are you considering? 2.02. Very good. So now you are going to first make your first conclusion that the time of flight is going to be 2.02 seconds because it is less than the 2.1 seconds. Therefore, the launching angle or the angle at which the ball should be launched should be the angle that yields that 2.02. So the angle to launch should be 8.7991 degrees because the time of flight the ball takes is 2.02, which is less than the 2.1, which satisfies the condition. Now, after obtaining that one, you go back to the second threshold. The second threshold wanted the maximum height of the golf ball does not exceed that above the field. Now, you are going to go back. You are going to go back and also calculate the time or the time the ball takes. Now, to get the maximum height, you remember from your equations, how do you get the maximum height? Now, there are two ways you can do it. You know that v squared is u squared plus 2as. Now, since we are doing vertical motion, v squared is always equal to u squared. Since the particle is moving up, it's going to be 2gh, whereby h is the height above the point of projection, the maximum height above the point of projection. Now, you know that at maximum height, whenever you kick a ball, the ball will go. Once it reaches the maximum height, it comes back. What does it mean? It means that at this point, the velocity is 0. So that means that here, you are going to have 0 squared. But since the ball is moving up, we say that initial velocity is u sine theta squared minus 2gh. So now we shall have 0 is equal to u, which is 49, sine of our angle, which is now 8.799, everything squared, minus 2 times the 9.8h. So when you make h the subject, we shall have 49 sine of 8.799, everything squared. Then we divide by 2 times 9.8. Now, this one is going to give us our h as 2.866425. Now, when you go back to the scenario, now that height you have obtained is this height, members. This height here. This is the 2.866425. But they wanted the maximum height, meaning that now you are going to add on this height here, which is 4.9. So I'm going to come here and I say the maximum height above the field. So this is going to equal to our 4.9, then plus 2.866425. And this one will give us our 7.766425. And these are meters. Now you go back and make now the second conclusion. The second conclusion is going to come from there. That the second one, the maximum height does not exceed 30 meters. Then you are going to say that since the maximum height above the field is 7.76642 meters, which is less than the 30 meters, therefore it satisfies the condition for the ball to be launched. Now, from there, that is how you are going to respond to that. And then the ball lands within the targeted area at B, and which it did so. Now, that's how you conclude for part A. And therefore, your final conclusion should be that determine whether the technique satisfies the academic training requirements. And therefore, since the two conditions are being satisfied, therefore, the ball satisfies the academic training conditions. Kindly let me know through the chat whether we're on the same page. Are we on the same page? Are we on the same page with those conditions? Okay. Yes. People are saying yeah. Okay, let me have a question. Manzi Kalal ask. Ariana, I'm seeing your hand up. Manskal ask. Ask. Okay. 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 Akibua, if you could unmute, unmute. Akibua SS, kindly unmute and let me know the part where you want some support.
It is from the equation b square.
Yes.
Equals, it is from the equation b square is equals to u square minus gs.
Here.
Yeah, that part.
Yes. How
you got that u sine theta square.
Oh, now since the ball is moving up, we consider the vertical motion. Now for vertical motion, your initial velocity for vertical is always u sine of alpha. This is alpha. So you substitute where there is u. Is it fine or not yet?
It's okay, it's okay.
Okay. So because of the vertical motion, that's why we substituted. This is supposed to be alpha. Okay. Now we go on. Gideon. Okay. Gideon Mungululu Sid says, and then Philip. Okay. Zubi.
So I would like to know the maximum number of DPs.
For?
See, the DPs are many.
Oh, now the more number of DPs you have, the more accurate you are. So if it is for any value, 4 DPs is very good. 4 DPs is very good. You are very accurate. Unless when the question has asked you to write a given thing. But the more number of decimal places you write, the more accurate you are going to be. So that's what we said. Avoid premature approximations.
Thank you.
Yeah. But if it is time, 2 decimal places and above is okay. If it is for angle, 2 decimal places and above is very okay. But if you are still using that value, please carry many decimal places such that you are very accurate. Because sometimes you may make a wrong conclusion because you rounded off to few decimal places. Yeah, there are some values. Now here, are you seeing this answer? Like this answer, for people who are rounding off to a very few decimal places, you may find that your answer was close to 2.1 or it was 2.1. Now, for such a case, your conclusion is wrong because you did premature approximations. Okay, we go to the last part. At the instant of the golf ball is struck, the maintenance vehicle starts moving towards point B. Along a straight service road, the vehicle is initially 24 meters from B and it travels at a constant speed of 12 meters per second. According to the Academy safety policy, practice will continue only if the maintenance vehicle reaches point B before the golf ball. Now summarize. They have given you the distance, which is S, which is 24 meters. They have told that the speed is 12 meters per second. However, they have said the speed is constant. Members, whenever they say that the speed is constant, it means that acceleration is 0. Constant speed means acceleration is 0 because speed is dependent, acceleration is dependent on a changing speed. So for that case, it means that you are going to use your equations of motion. So you are going to come and say, what are they interested in? They are interested in time. So we shall say that S is ut plus a half of 80 squared. Now, initially the particle was 24 meters is equal to initial speed, which was 12 times the time, plus a half times a. But since acceleration is 0, we shall put 0 times time squared. So we shall have 24 equals to 12t, and therefore we divide by 12, divide by 12. And here we are going to have 2 seconds is equal to our time. And here let t is equal to the time taken by the vehicle to reach point B. Now, you note that the time here we have obtained is 2 seconds. Now, what are you going to compare it with? Remember, the time taken by the particle. Remember, as this particle was starting, also this was moving. This ball took 2.02 seconds. The particle took 2 seconds to reach there. Now, what does it mean? Because the condition here says that according to the policy, practice will continue if the vehicle reaches point B before the golf ball lands. Now, members from the chat, you tell me, did the vehicle reach there before the golf landed, or it reached when it had landed? In the chat, what do you think? Did the vehicle reach there before, or it reached after? It reached there before. Thank you, Saint Matia Murumba. Now, that is where you are going to conclude before. Very good. So you are going to say that since the 2 seconds is less than the 2.02 seconds, the vehicle reached there before the ball landed. And therefore, what should the academy do? The practice should continue. Now, that is the conclusion you need to make. That is the decision you need to make, that the academy should continue with the practice because the vehicle reached there 2 seconds before the other ball landed 2.02 seconds later. Now, that is where you have to conclude. You need to always conclude and make a decision. Compare, make a comparison of the values you are obtaining. Yes, so we expect your conclusion to have a decision. What decision are you taking? That the academy should continue with the practice. Why are they continuing with the practice? Because the vehicle reached there 2 seconds and therefore it was able to fulfill the policy, the safety policy. Okay, let me take a hand from Sevino, Ariana, and Ngola girls. Ngola girls. Ngola girls. Okay, I failed to get Ngola girls. They are not speaking. Carl. Okay. Top times.
Yes, I would like to inquire how could I have used the equation of trajectory so that I obtain the other values instead of maybe doing one at one.
Okay. How you'd have used the equation of the trajectory to obtain. Okay. Is it the same question? The person not. Okay. Okay, I'll mute you. Now, for the equation of the trajectory, those who want to use it, you do have now the equation of a trajectory is given by y is equal to x tan of alpha minus g squared out of 2u squared into 1 plus tan squared of this. Now what you do, your y here for our case was negative 4.9. Your x was the horizontal, which was 98 tan of alpha minus the 9.8 times your 9.8 squared out of 2 times, was it 49? 4.9. I need to be sure. It was 49. And then here you have 1 plus tan squared of alpha. Are we on the same page? Oh, the person who asked. Now, when you reach here, this would have been negative 4.9 is equal to 98 tan of alpha. Then you get your, where's the calculator? You get your calculator, 9.8 squared. Yes. No, this is 98, not 9. This is 98. Don't put this point. It is 98. 98 squared times 9.8 divided by 2 times 49. So here you'd have remained with 960.4 into 1 plus tan squared. Then what you do next here, you form your you can form your quadratic equation and then you solve. So sorry, this is squared. I think here I've also made a mistake. This was squared. This value here is going to change. That is, allow me to change it, divide by 49. So here you'll get 19.6. So then you continue, this is negative 4.9 is equal to 98 tan alpha minus the 19.6 minus the 19.6 tan squared of alpha. Then you collect like terms, 19.6 tan squared alpha minus 98 tan of alpha, then bring the other this side, 19.6 is equal to 0. So you end up with 19.6 tan squared alpha minus 98 tan alpha, then negative 4.9 plus 19.6, which is 14.7 is equal to 0. Then you solve this and then you'll get back at the same page like us. Yeah, so that is how you do it. Okay, hope I don't know which school it was, but that's how you can do it using the equation of a trajectory. But now here, the only challenge with it that should you make any error, let me say, God forbid, you substitute here with, let me say, another value, or you come here instead of G, you substitute with another value, maybe 9. Everything that follows is going to be wrong. Because we don't give any mark for this, for the formula, but it is correct substitution in the correct formula with correct values. Any error, you are off. That's why I always encourage us to use the step-by-step, such that at least there is something you can pick along the way, instead of just failing something completely. Okay, Philip, Cool, Ariana, JV. Yes.
Thank you so much, sir.
Okay. Philip, I'm not getting you.
Okay. Thank you so much, sir.
Okay, Philip, I'm not getting.
I have a concern. Are you getting me? Are you not getting me? Fix your mouth. That's it. Are you getting me, sir?
I went off. I was asking, I was not getting Philip.
Okay. Are you now getting me? Yes,
Yes,
sir.
I'm getting you.
Okay, thank you so much. Like my concern is only one. In the for this lawn to be suitable, the third rule is that the golf ball lands within the designated target area at B. Is it not necessary that we also first of all determine the distance?
You find it? Oh, you find that now here,
Horizontal
why
distance
now
to
the horizontal distance
between 98 below 0.
Okay, now,
Thing.
the third condition,
Yes.
it is okay. Let me share again.
Okay.
Let me share again for the third condition. Oh, where is that now? Okay. Oh, sorry, I want to share that item. But it was it. Yes. Now that okay. Now, when you look at the third condition for the horizontal distance, if you make your calculation, it will be u cos of alpha times t. So this is 49. And when you look at the what? At our cos was 8.799, then times your time, which is 2.02385. Now, when you make your calculations, you will see that 799 times 2.02385, then times 49. So you'll see that your answer is 98.00. So it is already within. So that condition, even if we had not used it, it was redundant.
Okay. Thank you, sir.
Okay. But you can calculate and show, and you prove whether it is okay.
Yes. Okay. Bye. Thank you.
Okay.
At least.
Ngola girls, Ariana, Sema, okay. I think I've failed to get some of the what? Of the people who have raised up the hand. But in case of any question, you can place it in the chat. You can place it in the chat. Now,
You know I want.
yes,
Yes, sir.
yes, please go on, Ngola.
Okay, sir. We want some help. May you display the question, the item part 1, please?
Which item?
That very item, but the beginning part.
The beginning part,
Yes.
Is it there?
Not yet. There. Okay. Remove the black. Okay, remove. You first remove the black. Yeah, first remove. We are trying to photograph the question.
Hope I have removed.
Yes.
Yes.
Okay, thank you so much. Okay, thank you so much.
Okay.
I thumbs up. When I get thumbs
So
Yes, please.
I joined a bit late, but is there any chance that you covered some items on coordinate geometry too? Because I joined like an hour late.
Yes, we covered some, but we
Is
shall
there,
keep covering. Not I am, but today we have mainly looked at coordinate. Today we have not done anything on coordinate geometry.
are there any other sessions? Because
Yes, we shall.
it's a bit challenging.
Okay. We shall have more sessions on it.
Okay, I'll wait for the communication.
Okay. Then I'm just looking through the chat to see whether there is any concern, but I'm going to ask you to put your videos on. You can have your video on. Then someone is asking, when are we going to have? After this week, starting on the starting 13th that week, we shall have 2 full weeks of facilitations for all the subjects. Starting that week, we shall have, starting 13th, we shall have 2 full weeks of facilitations for all subjects. However, those facilitations will be starting at 4 p.m. to 6 p.m. So you can plan better. That is starting that week. We shall have those full facilitations. And maybe for mechanics, what I want to add you, always have a diagram. Whenever you have a diagram, it becomes very easy for you. Make sure that whatever thing you put on the diagram talks. Don't just put their values. Ensure that you put values, you put the direction for the forces, where resolving is needed. Make sure that you resolve very, very well. So I'm going to say that I think unless there are some questions we have not been able to do, but I'm just praying that time allows. I will be doing many of those items, and I will be sharing with you on the YouTube. You'll just be checking on our YouTube channel. We shall be posting them there. Otherwise, I want to thank you so much for joining the session. I want to thank the teachers who have connected you online. Teachers, I will ask you to take some photos of those students in those seminar rooms and you share with us. I wanted to capture this night one, the night thing. Now, some of you have challenges with, let me say, wait. Someone wanted things concerning projectiles. I think I had promised Ariana something concerning something concerning what? Something concerning projectiles, but Ariana, I think let me send you here. Ariana, you are going to look out for this YouTube channel of Holistic E-Learning Platform. Now, once you come here, come where you have playlists here, the playlist, and then come in the playlist, you'll find the different topics. You are going to find differential equations, you are going to find projectiles, you are going to find trapezium rule, you are going to find trigonometry, you are going to find integration, you are going to find curve sketching 2 and all vector and all. You are going to find vectors, you are going to find individual projects, you'll find partial fractions. So come here. Many of those things have been captured here such that you can be in good. Farm SS, I don't know whether Farm SS, the teacher has taken for us some photos of Farm. I saw Farm SS in the darkness. We are happy to have all of you. Matia Mulumba, you wanted to lead us in a word of prayer. Kindly unmute. Matia Mulumba. You can pray for us.
Loving Father, thank you for this time. Thank you for this evening of glory. You know it, you knew it even before we came into existence, Father, that we shall have a time like this, Father, to share something vital in our understanding, Father. Thank you for being with us and leading us through everything we have received, Father, and it has impacted on our understanding, King of glory. And may it stick in our minds, Father. Jesus' name we pray and believe. Amen.
Atamani kasa. Mwenye nasala neba wuli.